Welcome to BALLBUSTERS Live. I'm your host Nathan Oakley, and if you are new to this channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they are live, and there is also a PayPal, Patreon and crypto link in the info box below this video. Now today on BALLBUSTERS we will be covering the wave-particle duality, and joining us to discuss this very, very important matter is Adam Meakin, Betty Van Velsen, Arwin and Quantum Eraser. Good to have you all.
Good evening, everyone.
Good evening. Good evening.
Ahoy hoy.
Ahoy hoy. So, this conversation drags out and always ends in the same exact thing being said by either John or myself, which is to say that light is particles. And we always have the same pretender clown, muppet, wiki parroting, crayon munching idiots saying, no, it's a wave. And we even get into, with some of our own side discussions about the ether. But John has done one presentation previously on this subject, which was called Science versus Scientism, and it was specifically about the double slit quantum eraser, or delayed choice quantum eraser. But in this instance, the presentation is going to be split up a little bit, so we will have an extra bit tagged onto the end where the audience will be invited to join. So we'll open up the phone lines, if you like, to the public, and it'll be done in the same format as the debate, so you can join via the link, which I'll give you a heads up when it gets published in the info box, and then you'll just need to refresh the page if you're watching live, and you can actually join a little holding pen that we will have, so it'll be a little bit more controlled than the debates, and hopefully you'll be able to formulate amongst yourselves, if you're in that panel, a question that's relevant to the actual subject being discussed. So obviously we will tolerate no fools in this instance. We'll hope for concise questions that are actually relevant and answer them on the spot. So it's not going to be a echo chamber, but there will be a presentation which will be split up by comments from the panel in the first instance, and then, as I say, I will give you a heads up in the audience so you can join and actually pose some questions to any of us on the panel. So, where do we begin?
Hold on, before we start, I was kind of disappointed that you forgot to mention the beam concept that I brought forth. That is also an option, in my personal opinion, about the supposed duality. That's not really a duality anymore then, in that case. So, yeah.
Didn't last long then, Arwin. Didn't last long then.
The beam light concept is basically instantaneous. It's an instant connection. That's how I see it. Anyway.
Well, we may not disagree.
Carry on.
We shall see. So I think I'll pass the mic straight to you, John. So where do you want to begin?
Yeah, it's going to be a little unique this time because I haven't done this before. I figured I'll just go with the older presentation that we did because why screw around with perfection, right? And it saved me a lot of time, you know, because whenever I do presentations, I always get in a bad habit of adding new stuff, taking stuff away, and it just gets a little discombobulated. But this is kind of unique, where we're just going to go with the old presentation. We're not going to go through the whole thing. We're going to go through halfway. We're going to stop sort of halfway before the crux of the matter is adjudicated. And I wouldn't say that this is a strictly photons or particle presentation. It's not. It can turn out to be in the end, but it's not. I'm assuming that, and I'm assuming that because it's true. However, like I said, it's not strictly that. It's the wave. We're going to stress today the wave-particle duality and why that's sort of a misnomer. And it's just a linguistics issue. And then we're going to get to the meat towards the end. But we're going to leave those questions up in the air for next week. And then we'll go through the experiment that adjudicates the answer to the question that we're asking.
Cool. Just before you get into it, I will say also that within this presentation we'll be covering the ontological primitives, which we'll get to as well. So, do you want me to stick your screen up, John?
Yeah, go ahead. Let me know when it's up, and let me know when you're ready.
Yeah, ready to go.
All right, let's roll.
Ready when you are.
Volume is low.
We can't hear you, John. For some reason, you've now lost sound.
The video volume is very low.
Oh, is he playing the video? Yeah, the volume's too low to do that, John.
Well, he can crank that up with the mixer. Yeah, try it again.
Stay here for
No, 30% better, not a lot. Nathan, perhaps you could play
I can't
it
do anything.
from your system?
I can't raise the volume individually of the video that he's playing, unfortunately, Arwin.
No, but I mean, if you play it from your system, then maybe you could get the full volume in.
Okay, this is going to take an eternity. What do you want to do, John? The audio's useless.
Okay, wait a second. Let's try it one more time.
Can't you just play this from Nathan's station instead?
Hold on 1 second. Hold on 1 second. Let's try it one more time.
No, just nothing. This is just going to be useless.
No, 50%. That's it.
Hold on 1 second. Let me come back out and try it one more time. This was working perfect yesterday. So, hold on.
You just have to gonna pull out the boombox and put maximum blast so everybody in the neighborhood can hear it.
Nothing. Just got nothing at the moment, John.
You got nothing.
No.
Unbelievable.
Nathan, is it really tough to, just open up another Firefox or whatever browser and just play it from there directly so you can have more control on the volume?
Yeah, but then I don't know when to stop it and start it.
Yeah, I can tell you that. No, that's no problem.
Okay, just give me a second. My apologies for the dead air in the audience.
Whilst it is a bit of dead air. Owen,
Yeah? What is it, Adam?
did you watch last night?
Yeah, with Crow. Oh. Yeah, that was really good.
I thought
Yeah.
you think it was.
Yeah, I even mentioned it on my early bird show this morning, and that is that I think I kind of underestimated where he was at because I haven't kept track of him at all. Just remember him from the Moon Ripple, and kept a bit my distance because he was so much in gematria at the time. But now he's moved on, doesn't refer to that stuff as much, and he was just really good on Iron Realm. So yeah.
What did you think of the observation then?
Well, I to be fair, I was pretty preconceived in my approach to it because I was suspecting it was going to be a lens flare alike side effect, but yeah, not just like lens flare with cameras where moving the lens angle will shift the lens flare, but a more direct effect that could potentially even be perceived with the eye. But I still think because of my assumption of the holographic nature of the sun as it being a light side effect, that such a secondary sun disk, apparent sun disk would be somehow a side effect that would appear in such conditions. And I don't know even the nature of the conditions. I can't just say, oh, it's atmospheric. No, it could be the mysterious nature of the energies of the globe of the heavens themselves that could somehow allow this secondary sun phenomena to manifest at a certain time. Where to begin? The mysterious nature of the globe of the heavens, what causes all this? But it was a good presentation, and I really liked Crow's in-depth thought on historical matters and everything. So it was very good.
That sounds like you've got the same opinion as me. You don't know what it is either.
What is? The secondary sun?
Whatever the first or secondary. I mean, with what Chris Van Matre caught with the power cable.
Hold on. Let me approach it just right in there. Look, if there literally is a secondary sun, then you should be able to measure it with shadows. So you have to have then, from the sun alone, 2 different type of shadows, like say on a stick. Let's get very old-fashioned. And then, if that happens, then okay, there's literally 2 different light sources. And who knows, maybe in some way at certain times the sunlight doesn't just come from one singular direction, but actually several. In my conceptualization of what could cause daylight, some kind of critical mass induction like effect from high atmospheric electricity causing the daylight to manifest, then maybe a secondary sun could just appear at a certain time and daylight would be coming from 2 directions. I don't know.
Shout out to James Mayers for the super chat. Really appreciate your support. Sorry this is taking me so long.
All right. By the way, the volume came through pretty loud and clear.
Sure.
Hey, Nathan, I put the stops in for you.
Okay, is that in Skype?
Yes.
And it's Science versus Scientism, Quantum Mechanics Double Slit, and Quantum Eraser explained.
Yes. Start at 150. Let me confirm that 1 second.
But Adam, to get back to the subject, for example, have you seen the blinking sun videos?
Yeah.
So just even approach that scale and then just realize that whatever is causing this apparent sun disk and the daylight, it is not just an object that is like a flame out there in any way, because that could never cause that thing to happen. Basically, it doesn't make any damn sense. It must be electrical in nature somehow. Correct?
I don't necessarily, not from those images do I draw those sorts of conclusions. It was more, I'd done some myself with lens stuff with the moon, where we got both a kind of bright focus of the light and then a secondary image of the moon behind. Like you said, when I first looked at it, you're thinking, is it optical flares or is it just lens issues? But those guys know exactly what they're doing, and those images were just odd. Yeah, they're not standard. There's something very unknown about what is causing it, and I think the secondary thought of somehow the atmos plane itself rendering the image we see was something I'd pondered on, and that's just as relevant, ball or flat, I think. However, this energy is then interacting with the atmos plane above us. Is that the actual visual image we see? Was the thing I was taking from it.
Yes, I think that in some way, almost like a light bulb, but in the air and not so local in some way. Light just is a natural side effect. The daylight in that specific angle in relation to your position is a natural side effect of what goes on up there.
Right, I'm ready to rock and roll with this, so I'll start with that first little section and then we'll discuss it afterwards. Has the presentation changed much since you did it last time?
Yeah, I added a few different things in there. It's, I could go on for about, 20, 25 hours. So I switched it up a little bit, kept it current, and concentrated on a few more areas and dropped a couple areas. So let's see how it goes.
Cool. Well, without further ado, let me know when you're ready and I'll stick you up on screen.
Yeah, go ahead. Let me know when it's up.
Yep, ready to go.
All right. So before we get into the main event, I'd like to stay here for a couple minutes. It seems that on both camps, people just aren't getting this. So let's stop here. So again, paleontology, anthropology, archaeology, geology, evolutionary biology. Yeah, I'm still laughing. Theoretical physics, that's non-experimental. And then our genre, astrophysics, astronomy, and cosmology. These guys, these are not friggin' sciences. I don't know how to say this any differently, but they're just not sciences. I don't know what I should do. Maybe get it notarized or something. I don't know. These guys can't perform experiments. So they're not sciences. If you can't perform experiments, then it's not science. It's just as simple as that. But I don't know. We just get people in here talking about these as sciences. Why? It's by fiat, just the name. Crocheting is more scientific than these clowns combined, right? The first 6 pretenders, these guys, they can't even get into the scientific method. That's science. Observe a phenomenon. They can't get there without a time machine, right? The final 3 masqueraders, like I said, the ones in our genre, they can't formulate scientific hypotheses because they lack viable independent variables. It's just that simple. They can't isolate and test and validate their dependent variables or their predictions. A scientific hypothesis, it's a hard stop. It's over right here. Now, the true sciences are quantum mechanics, that's physics, genetics, chemistry, biochemistry, and biology. And remember, there's a caveat with these guys also. Each claim from any of these disciplines must be accompanied by experiment, preferably repeated, validating each claim. Now, if one of these guys come out, let's say from quantum mechanics or any of these guys, with a claim without experiment validation, well, you can dismiss that claim. However, you can't dismiss the discipline. Right? You're not throwing the baby out with the bathwater here. You just dismiss that claim that's not supported by experiment and you move on. Everything else is good. If no experiment, that equals cod swallow horse pucky. It's just that simple. So do not fallaciously indict the actual sciences as pseudosciences, as these guys, right? They're not the same. I mean, I even ran into a post the other day, and I'm sure we've all run into these throughout the past 3 years. Well, what do you got to say about the technology of the past 100 years? Well, I don't have to say too much about it, right? Because that technology was afforded by what? It just happened to coincide with the development and advancement of quantum mechanics. Well, I don't have a problem. We're good to go. I mean, we're not talking about these guys, are we? Are they trying to somehow take some veracity from quantum mechanics and put it onto these guys? What? You know, show me the MRI that geology has provided, right? Or the laser from cosmology. Right? It ain't going to happen. So it's quite ridiculous. And maybe this will help. I don't think so, because I've been saying this for 3 years now. It's both camps too. Well, our war is against science. Really? Your war is against these guys. Best wishes. Because the door's going to close on you pretty quickly. So if you want a war against these guys, that's fine. Because these are pseudoscience pretender clowns.
Okie dokie.
Yeah, any comments here? And thanks, Nathan, for being flexible. It was a really good job pulling that stuff up, man. Good job.
Oh, blatantly and obviously correct.
Yeah, so this is a big problem. Obviously, it's a big problem with flat earthers, because they know that they can't. They know they've been lied to by what is called science, right? And they conflate the actual sciences with the pseudosciences. So they throw the baby out with the bathwater, since cosmology, astrophysics, and astronomy have lied to them, along with the other clowns. Then that means to them that all science is pseudoscience. So I try to stress this every time to make that delineation between the pseudosciences and the sciences.
Yeah, I totally agree. That does actually happen. When people overly focus on the theoretical, this can totally disrupt their entire being once they figure out that it is truly all just theory.
Well, watch out with that term theory, too.
I was going to say, it's the pseudoscience bit. So only the other day I was watching an Owen Benjamin stream, who's live now, and he was talking about science betraying people. It's like, no, science hasn't betrayed anybody. Science can't betray people. It's a method. Pseudoscience, pretender clown muppets, they're the people who've betrayed you, not science.
Exactly. And hey, Nathan, just logistically, you don't have to start at 11:21. Just start where it stopped. All you have to do is worry about the stops.
Okay.
Just let it play. So go from 6:12 when we start up. Just let it play and stop at 11:21 for the next stop, and just let it play from then on out. You don't have to adjust.
I see. So from 6:12.
Yes. From where we stopped the first time.
Okay.
So if you want a war against these guys, that's fine. Because these are pseudoscience pretender clowns. All right. Quantum mechanics. Utter these two itty-bitty words to the majority of people and witness firsthand this, right? We've all seen this before. I'm not talking about the pretender clowns. I'm talking about, you're just regular everyday Joes. Sometimes I'll do it, around family gatherings, a whole bunch of people's around or friends, and I'll just bring up the term or the phrase quantum mechanics and just observe people. I'm not going to talk anything about it. I just want to see their reaction, right? Even with people that don't know what these two terms mean, right? I'm going to get this look or a rolling of the eyes. Even grandmothers, right? They'll be shaking their heads. They haven't even heard of these terms before. Talk about a conditional response, right? Where'd they get that from? Why is that? Most neither have the time nor the inclination to bother with such things. But for the layman who informally tread into this area are immediately confronted with numerous barriers, right? There's background noise, mathematical formalism, snake oil prognostications. Even if you go the formal institutional route, 99.9999% of the time of your undergraduate and graduate level studies will fall immediately into this category, right? Shut up and calculate. Richard Feynman coined this term. So, Professor Nicholas Geeson from the University of Geneva. In short, then, the mathematical formalism of quantum theory provides no explanation. How many times have I talked about this? Mathematics can only describe. It can't explain anything. It can only describe the what. It can't give you the how or the why. This gives the how and the why. So, again, in short, then, the mathematical formalism of quantum theory provides no explanation, only a way of doing calculations. Some physicists conclude that there is nothing to explain. Shut up and calculate, they would advise us. But wait a second, this is physics. We need explanations, not descriptions. Any idiot can describe something. We need explanations, we need demonstrations, we need illustrations, preferably with experiment. That's what physics is. We're talking about science here. Well, there's a method to their madness. Since the majority of scientists, which most professing are not, have an a priori adherence to their fairy tale religion, philosophical naturalism, realism, that's atheism, which is scientifically falsified, by the way. We're going to get to that. The irrefutable experimental evidence in the literal thousands without exceptions of quantum mechanics, the most successful branch of physics in the history of science, stands in direct contradiction to it. Puts them in a very difficult and uncomfortable position, vice-like. You can either reckon with the scientific evidence, and there's boatloads of it, and adjust your worldview accordingly, or close your eyes, put your fingers in your ears, and say, la, 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 shut up and calculate over and over again, and let cognitive dissonance rule the roost. Then what you do is you start erecting barriers and begin labeling it as quantum, weirdness, spooky, strangeness, absurdity, paradoxical, bizarre. You're going to hear these terms in the literature, in the scientific literature. You know, that denotes a fringe science, which is the exact opposite of what it actually is. It surely is all of those if you're wearing philosophical, naturalist, realist, or atheistic glasses. Take them off. But no, can't have that. They then conjure and float up mind-numbing interpretations. What is this, religion? Right? There's no interpretations in science, in the scientific method. It's black or white. It's a 1 or a 0. So this is nonsense right from Jump Street. You know, they got ad hoc and rescue hypotheses. The most popular one is the many worlds or multiverses, right? Well, that's like conjuring invisible three-toed gnomes. Many worlds, show me another world. That's what I thought. It can never be confirmed or falsified. So use it as a get out of incoherent jail free card to cloak their mind-numbing adherence to fairy tales with the facade of science, which are merely clumsily contrived just-so stories, to obfuscate having to give account for their ludicrous scientifically falsified stance. They're busted, and they know it.
Yep, they're busted. They're busted. What they try to do is go with the shut up and calculate. Hey, just shut up and calculate. Don't think about this stuff right here. We don't want you critically thinking about what's going on here. So just shut up and calculate and continue to do that and whistle past the graveyard, because there's two components of quantum mechanics. One, the technological aspect, which has brought us out of the Stone Age. And number two, which doesn't get talked about out there all that much, and when it does, it gets snuffed. There's philosophical ramifications to this stuff. And they're quite stark if you're an atheist. So that's why they do it. That's why they act dumb. Most people don't act dumb. They are dumb. Most of the so-called scientists, right? They're not acting. but a lot of them do act, and they know exactly what they're doing.
You mentioned the philosophical aspects being incorporated in the experimentation before. Was that something that you were well aware of before you mentioned it to me the other day? Was it just not mentioned on the other presentation?
What's that, Nathan?
The ontological primitives are part of the setup, part of the experimental setup. And you mentioned that to me the other day and then explained what you meant, and then it obviously clicked because I'd got a full explanation from you. But was that something that you left out of the last presentation because it just... you hadn't realised it, or what? I don't really know.
I whistled past the graveyard by it. I didn't realize it until after the presentation was over when I first did it. And I said, oh my God, I left a hanging watermelon-sized curveball out there. And I set myself up and I didn't swing at it. So we're definitely going to hit it this time.
Okay. Anybody else got any comments so far?
Nope.
Nothing too major, other than, this has nothing to do with flat Earth. This is quite a long-standing debate and is indicative of the power of quantum mechanics and the trouble it causes in terms of mainstream paradigm and perspective. That is a bit like flat Earth, isn't it? It's come along and it's got lots of logical and in the case of quantum mechanics, experimental data, which absolutely opposes the current paradigm and the current standing. And it's...
Well, I think that some of the outcomes of quantum mechanics can add to the flat Earth because time and space, right? But I think that we will get to that later. So, what is time and space? And what is information? All interesting things to consider in this experiment. It is really interesting to find out the conclusions that what they come to in the end. So but we will get to that, I think, later on.
Well, maybe. I mean, this is kind of linking the end conclusions to what John said in the intro, which is to say that we've got the same standards laid down. We've got wiki-parroting pretender muppets that are actually pseudo-scientists masquerading as scientists that are going to try and explain this away in their narrative, aren't they? They're not just going to stop lying about what they lie about just because something comes along that's experimentally valid. I mean, why let real science stand in the way?
Yep.
I was talking about this yesterday with somebody about a lot of things in scripture. When I was reading scripture for many years, a lot of things would just jump off the pages, and it's what I like to call poetic justice. Seems like the Lord likes poetic justice, and quantum mechanics is the atheist huckleberry. So it's going to get good.
They need it in their technology, but they have to shut up about the consequences that comes out of this.
Exactly.
Yeah.
Hey, do me a favor, guys. When we start running the presentation again, can everyone go on mute? Because I'm getting echoes.
You get muted anyway. The audience doesn't hear you. Shout out to 10 to the minus 17 Tor for the super chat. Really appreciate your support. Right, should we get going again?
Oh, before you go, I want to do a shout out to Delth Fader, who's been very comedically trying to troll me in chat.
Yep,
and also he appeared on my channel this morning, supposedly as a speech impeded person that on my panel had a spasm attack, according to himself. And now he's seriously trolling the chat everywhere I go since then. So shout out to you, Delth Fader.
Yeah, shout out retracted then?
Yep, that's the one. Shout out retracted.
So let's go here. Richard Feynman. He's pointed out that every statement in quantum mechanics is just a restatement of Heisenberg's uncertainty principle. Well, what did Warren Heisenberg have to think about all this? And again, I had this on the last presentation. The first gulp from the glass of natural science will turn you into an atheist. But at the bottom of the glass, God is waiting for you. He knew this. All these guys knew this back then. They knew more about the meaning of quantum mechanics back in its infancy than they do now. It's astonishing. I mean, the computation power has increased exponentially. However, about the meaning, they were all over this back in the day. So basically, the uncertainty principle states that the more accurately you know, that's going to become very important here in a few minutes. The more accurately you know the position of a particle, the less accurately you know the momentum of that particle, and vice versa.
Right.
Okay.
So I wanted to stop there and stress this because just for an example, go ahead and put that back up again, Nathan, that,
Yeah, sure.
that citation from Werner Heisenberg. Just put the screen back up.
Yeah, up.
Yeah, could you imagine, let's say Werner Heisenberg just received his Nobel Prize last week, and during the Nobel speech, he said this. What in the world? What do you think would happen to him? Right? I'll just leave that out there. Let that marinate.
Right, I'll press on unless anyone's got anything.
Before you do, Nate,
Yeah, go on.
The bit with regards to the more accurately you know the position of a particle, the less accurately you know the momentum. This is one of those ones that I don't understand or pretend to. It's one of those things that kind of means that reality defines physicality.
Not reality, no.
Reality
doesn't define physicality.
Perception.
Perception.
Observation defines the reality.
Yes.
And remember, this is not cause and effect like this is law, like the uncertainty principles like a law. This is just what it does.
If I put it, I don't know. This may be a waffle, but the way I'm thinking is the more you, as the observer, want to define its position, the more the particle has to behave in uncertain ways to ensure that it's there for you to observe.
That's a stretch.
It adapts to the observer.
Yeah.
It's basically the concept of the matrix of reality, the physical reality defines itself as it is being contacted by your consciousness.
Yeah, I much prefer Aaron's way of putting it, Adam. Sorry.
That's good. Like I said, this is my... Well, say it again, Owen, for me.
Okay, so the world actually defines itself the moment your consciousness contacts it through some observation.
That's fine. I'm talking about how the particle behaves once you're observing it. So just relate that concept to what the particle's doing as
well. It has an influence.
Locate its position. So
I have a certain question about this concept of the dual slit experiment and the supposed observer changing the course of the presupposed particle or the result. And that is, have different types of subjects been tested? Or is it just a couple of people and it turned out to be okay? This is
people, really. It's
because
detectors.
Like, what type of consciousness would, for example, a very focused Buddhist monk yield the same result? No, I'm serious. Would they yield the same result, or would they be able to bypass the observer through their focus, the observer effect?
I just want to bring some clarity because
leave the particle unabided.
I just want to make a distinction, Owen. It's not the observation. Because you can literally, and this is in a link below this video, you can have the experiment running and observe it, and nothing will happen. Yeah, you still get your interference pattern. It's not the observation; it's the knowledge. It's knowing which path it went through, not just observing it. Because if you just observe it, you wouldn't know which one it had gone through.
Exactly. Exactly. It doesn't have anything to do with observation. Yeah, observation indirectly. It's knowledge of the which path. It's knowing. It's based on information. So there's a lot of people out there talking about the observer effect, right? And they're just muddying the waters because they don't know what they're talking about.
which is why
but that's a concept. You have no proof of
Yeah, you
physical
do.
proof
We've
of
got an
information.
experiment.
Yes, I do.
Yeah, we do. That's the point. But that's why I critiqued Adam, because he kind of put in the cart before the horse. It's the knowledge first, not the particle, if that makes sense. It's the knowing that comes. That's the first bit. That's the initializing stage. That's the cause.
Exactly.
Any more, or should we move on?
Go.
I'm lost.
That's okay. We'll bring. Hopefully, by the end, clarity will be forthcoming for everyone.
So let's get to it. I'll be talking about photons to limit confusion, but everything I discuss applies equally to all elementary particles, electrons, atoms, and molecules. So in 1801, Thomas Young shot a coherent light source through a double slit experiment, and this is what he got. All right? This isn't a model. It's not a prediction. It's just what he got. Right? Another important point here. You see these terms down here, interference and diffraction, right? They're synonymous. They mean the same thing. This is a diffraction pattern or an interference pattern. This is going to become very, very important here in a few minutes. Keep your eye on that. So from 1801 up through 1910, 1915 area or so, all they got was this pattern. So everyone just assumed light was a wave. That was it, right? But 2 consecutive Nobel Prizes were awarded in 1921 and 1922. Why? Well, each showed conclusively photons were actually particles. The photoelectric effect and Compton scattering. Now, I've whipped Einstein around by the short hairs for the last 10 or 12 years, but give credit where credit is due. You see, Einstein didn't receive a Nobel Prize for those fairy tales, general and special relativity, which aren't scientific theories anyway, by the way. He received it for this, the photoelectric effect, and it's well deserved. All right, so credit where credit is due. And Compton scattering, this experiment right here, it was the death knell. It sealed the coffin shut. Photons are particles. So from the chair of physics at Yale, everything is really particles. All things, electrons, photons, protons, neutrons, they are all particles. So let there be no doubt about that. Okay, there's no doubt about it. So, let's take a look at this. These are rocks over here. This is waves. This is rock or rocks, and in here are individual rocks or particles, and this is a wave, right? Hopefully everyone understands this. They're mutually exclusive. Now, if you're confused about this, go ahead and ring your call button. I'll have Tommy come back and hit you in the head with the tack hammer. So these are particles. This is a wave. For example, if you stand 3 feet away from me, I pick up a pebble and I hit you in the forehead, it's going to hit you in a distinct spot on your forehead, right? That's a particle. However, if I pick up a bucket of water and throw that on your face, the energy from that wave, from that water wave, is going to be spread out across the entire transverse dimension of that wave. It's going to hit you all over your face instead of one distinct spot. Now, we all know this intuitively. So, but we're poor, dumb animals, so let's have a scientist reconcile this, see what his thoughts are. So, Leonard Susskind, professor of physics at Stanford. Particles are particles and waves are waves. How can a particle be a wave? Wave in an ocean, that's not a particle. The ocean is made out of particles, but the waves in an ocean are not particles. Rocks are not waves. Rocks are rocks. So a rock is an example of a particle, and an ocean wave is an example of an ocean wave. And now somebody is telling you that a rock is like an ocean wave? What? So, hey, credit where credit is due. At least he realizes the nonsense here, right? I mean, it's over. However, what do we get? Well, we get wave-particle duality, right? Well, we just went over that you can't have that. And everyone knows this, right? It's like cerebellums or facultative anaerobe woodpeckers, right? They're incompatible. But that's what we get. So when this phrase, wave-particle duality, is uttered, what they actually mean is collective particles contrived wave-like non-duality. That's what they actually mean, and I'm going to show you why over the next few minutes. This is really important. I can essentially stop right here, really. I know you guys won't let me do that, but I could stop right here. From the chair of physics at Yale. So we have to play this game in two ways. It is particles, but its future is determined by a wave. But, and that's a very big but, the wave is purely mathematical, right? What's he talking about here? Well, he's talking about the wave function, Schrodinger's wave function or wave equation. You cannot put an instrument to measure the energy due to that wave. It's a construct we use to determine what will happen in this experiment. It's it right there. I can stop. But I won't. Where's the fun in that?
Okay.
Yeah, that's it. I could stop right there. I won't, but I did. I could stop because that's where the confusion comes in. This is where the problem with linguistics arises, because everyone, when they think or they hear the term wave, what are you going to automatically think of, right? A water wave. That's what everyone thinks of. We all do it. So, and I don't know if they do it purposely. I don't know, but when they say wave, it's got to be a physical wave. It is not a physical wave.
A wave if it is a medium fluctuation. A particle is a unit.
Exactly.
Yeah, so we're not talking about the displacement of a medium then?
No.
Exactly.
So when somebody gives you a frequency of a wave in a different spectrum, and they say, well, here's a comparable wave, and it's no different to light, it's just a different wave, so radio wave. How would you get around their explanation that it's absolutely comparable to light, also a wave?
Because light's not disrupting a medium. You already said it with your last statement.
So is the other wave disrupting a medium? The radio wave?
Yes.
That's not a wave. It's radio are all photons. The whole electromagnetic spectrum are all photons, from radio waves to gamma rays are all photons.
That's what I was
So
saying.
it's just a
waves.
so
Sound
it's just
waves, though, do disrupt mediums.
Yeah, we're not talking about sound. That's completely different. All it is a simple equivocation fallacy.
No, not sound, but radio waves. So that's the bit I was waiting for you to say. So in essence, it's just not it's not disruption of a medium, and no different if it's higher or lower down the spectrum. They're all the same thing. They're all particles. The reason it gets described, there's that word again, as a wave is because it is a mathematical description.
Yeah, what it would do on a photoelectric plate. That's that interference thing that you see, that's mathematical, and that looks like how it would be in a wave. But that's the only thing that is calculated.
It's a mathematical deduction inspired by nature.
Yeah, because that interference pattern is just small dots on a photoelectric plate, right?
When this comes
it's just small dots. It's not a spread out thing. It's
exactly
dots.
It's dots, quanta. So John refers people to the description box below this video when we have this come up in live debate, which is to say that if you can see one singular hit a plate or a sensor, then it's not a wave. You can't have one being a wave. And if it was going through the double slit as a wave, you'd see a whole mess on the back plate, not individual hits, which is what you get.
Well, but I claim that the individual hits are based on a minimum of the critical mass required in order for a presumed photon to register, because if it's not going to hit with enough force, with enough energy, then it won't register.
Yeah, that might well be the case, but it's not a wave.
Hold on. Important question. How has the photon unit, the energy quantity, been established, and has there ever been a register of 1.5 photon unit energy quantity hits? Because then, to presume that it is a particle,
you have to look at the photoelectric effect. You have to look into that, because
is
that
the
explains
is the quantity of registered energy divided in a specific spectrum that would absolutely confirm that a photon is a specific energy unit?
Yes.
Or
yes.
The spectrum.
Yes.
Yes, it has.
How?
Is that a short enough answer from both me and John?
Can you back that up, please? I need to know.
Photoelectric effect. You have to see what that does, and
but the
when
energy
an electron is being released,
the energy quantity of the photon units.
We're going to have to put you in the holding pen, man.
Okay.
Yeah.
As long as I get an answer to these questions.
Well, if you would have listened to her answer instead of over talking her, then you might have got something.
Yeah.
Okay,
Yeah.
I got a yes, but
it's been explained by the photoelectric effect. You have to look into that, what it is and what it does. It has to do with electrons being released from an atom, and it can only be done by one photon.
Yeah, by a certain amount of energy.
Exactly.
So you're going to have to look into the photoelectric effect.
okay.
Maybe I can help you after. Maybe I can help you. Hold on.
I got a response, a critical one. So you base your photonic unit on this specific interaction of photoelectrics?
You have to look into that first, Arvin, before you can respond to it.
And you don't have to have...
Does that unit correspond with actual minimal registerable photons?
Yeah, energy and momenta. Yes, that's what makes a quanta. Each wavelength of light has a different energy and momenta. Correct.
Yep.
Can you give me the spelling of quanta, just for the audience's benefit as well?
I'm asking about energy quantities.
Quanta.
And I'm telling you.
If the minimum registerable quantity of photon energy with the double slit experiment does correlate with the exact exchange quantity in photoelectrics with solar panels? Is it the same quantity?
You're doing so well.
No, I'm trying to verify the actual unit.
Well, start listening.
If you first look into this, then you can make accurate questions. If you didn't see this, then you cannot make accurate questions from this. Then you're just basically making stuff up from nothing. You have to look into this. It has to do with atoms and electrons being released.
I understand the interaction. I understand the interaction, okay? I really do. I had chemistry and I had physics.
Well, it doesn't seem to be so, because otherwise you wouldn't ask this question this way.
No, but I'm asking for registered unit energy quantity registry. Like, how has it been confirmed that photons
by the
have a specific energy unit? How has it been confirmed that the photon is a specific energy unit and not just a minimum
by the photoelectric effect
registerable amount to trigger a reaction in specific type of circumstances, like photoelectric interaction or the absorption in a double slit experiment, which is a different process? I'm really trying to get to the core of this.
Then first go look up photoelectric effect. We have a video that you can watch, and if you have then questions, you can come back then later. I think that's best, because
Could you post the link? Could you post the link in Skype?
I will. I will.
Thanks.
I will look it up
Thanks.
later.
Thank you very
Okay,
much.
can you spell?
Sure.
Can you spell? I don't know how to spell it. Quanta. Anybody?
Sorry?
How do you spell quanta? Just so someone's got an
Q-
easy unit to look up.
T-A? Quanta?
QUA. Sorry, I didn't hear that.
Q-U-A-N-T-A.
Perfect. So
Quanta.
yeah, check it out. Single unit. Okay, should we move on?
Okay, thank you. Thanks for entertaining my very serious question.
No, I let it roll because it is an important question. So as frustrating it is to Betty and John, I see the validity in your question. Although you're not willing to hear the answer, which is fairly typical, but that's okay. That's good
No,
too.
I am. I
Sure,
will
so-
look at the links.
The photoelectric effect. Perfect. Any other questions? I'm happy for that bit to get dragged out. Hence, I didn't moan. Any more for any more?
No, I think it's an important concept. I've tried to look into photoelectric and tried to get my head around it a little bit, and it was regards to the cooling effect of moonlight. It's the transmission. I think it's the repassing on of the light wave, but it involves the energy within the substance that the light wave is reflected off. Is that what we're talking here?
Silence.
Yeah.
No answer.
No, I'll need further updates from the new source to continue this line of questioning. So
It probably is a bit complicated to go into, yeah. So, but it was stuff I looked at when I was looking at moonlight and how the energy changes as the photon is reflected, and how it can pick up energy from a reflective source. But yeah, so yeah, I'll stay away from it.
Anything else? Or should we move on? Because this is the real... I want that all out the way. I want everyone to get it all off their chest before we move on to the main meat and potatoes, which is this bit. Nope. Right, we'll move on.
So the double slit experiment results. These are typical patterns you get from the double slit experiment, right? You got the interference or diffraction. Remember that one now. Interference and diffraction, the same thing. And when you have photon slit detectors or detectors at the slit and you have the knowledge of the which path information, well, you get this pattern. So all are actually particles here. If you look real close here, what you'll see is there's discrete chunks of energy and momenta, i.e. a particle, that hits this photographic plate, right? If you could zoom in here on this interference pattern, you're going to see the same thing. There are particles hitting here. So the argument isn't over whether particles are hitting these detectors. Everyone knows this, right? It's the overall pattern that's the issue. The overall pattern. That's the game. Now, even if I fire one photon at through the double slit without any detectors, even one photon, let's say I fire one photon every hour for 20 years, this pattern is waiting for me. Even with one photon. You can have a stream, you can have trillions of photons, or one photon at a time, it doesn't matter. You're getting this pattern. Now, what is this? What does this look like? Right? It's a probability distribution. That's all it is. Again, it's the overall pattern that we're concerned with. And number 4, the Schrodinger equation. Now, what he did was reverse engineer this interference pattern. They got thousands of these patterns over and over again. Now, I'm not trying to diminish or slight Erwin Schrodinger for what he did. I mean, it was yeoman's work to come up with this wave equation, and he received the Nobel Prize for it. As a graduate, he did this as a graduate student. But what he did was reverse engineer this interference pattern. It's essentially a mathematical description of the superposition. It's a probability distribution, is what it is. We've all seen these before. Listen closely. This is very important. Again, from the chair of physics at Yale. you cannot mathematically derive any of quantum mechanics except looking at experiments and trying to see if there is some theoretical structure that will fit the data, right? That's what Schrodinger did. That's the textbook definition of what he did. Quantum mechanics, it's a theory which is based on experiment. It's not deduced by mathematics. So you see the dichotomy here. Experiments versus mathematics, and mathematics versus experiments. They're not the same thing. This is science. This is mathematics. Hopefully this is understood. I doubt it. So again, back to the interference pattern, right? It's just a probability distribution. Like we talked about before, we've all seen these histograms, probability amplitudes, probability distributions. That's all it is. And like I said, even if I fire one photon, every hour for 20 years, this pattern is waiting for me, right? Now, on these predictions, they're not scientific predictions. They're statistical predictions based on this pattern. So let's say I fired 1 million photons at the double slit, and someone stops me and says, okay, for the millionth and first photon, I want you to tell me where it's going to go. I can't tell them where it's going to go. Nobody on this plane can tell them, right? All we can say is that when the wave function is high, the probability is high, there's a good chance of it's going to hit here. And as the probability gets lower, it gets less and less. And when the probability or the wave function is 0, then you're not getting any photons here. Okay, so this is a statistical prediction. It's not a scientific prediction. Now, divining wavelengths. This is the game. So divining wavelengths from particles. And this S is very important here because they're not divining a wavelength of a particle. I'm going to show that here in a few minutes. It's particles. Now, this is a scale diagram showing what pattern you get from single slit diffraction down to 7-slit interference. Now, as you can see here, what's happening, as you increase the number of slits, the more defined and discernible this pattern is becoming, right? This is really easy to discern this. Now, instead of 7 slits, let's put 1,000 slits per millimeter. So what do you guess is going to happen to this pattern, right? It's going to get uber distinct and defined, and you can easily measure through here, right? So let me introduce you to diffraction grading, or better said, right, interference grading. This is going to be an interference pattern, right? So what they're going to do is they're going to take this monochromatic light source, fire it at the grating or the double slit, and in this case, it's thousands of slits per millimeter, right? They're going to fire them over to this detector, and what's going to happen? Well, we already know what's going to happen, right? We're going to get an interference pattern, but we're going to get distinct dots, right? We know this from the 7-slit. So what they do is, when they manufacture a wavelength of particles, that's important. What they do is they fire this monochromatic light source at this diffraction or interference grating. They take the number of slits, then they take the distance between the diffraction grating and the detector, then the angles here between the 0 order, 1st order, 2nd order, and 3rd order. Then they take the distance of these dots, right, between the 0 order and then the mean values of the 1st order, 2nd order, and 3rd order between these guys. And voila, what pops out with a little trig? The wavelength. But wait a second. This is an interference pattern. The interference pattern is governed back here by the wave function. But we already discussed that the wave function isn't real. So you're getting a wavelength, something real from something not real? What? And remember, this is particles right here, right? We can debunk this real quick. With one particle, I want a wavelength for a particle. So what I'm going to do, I'm going to put the most premier physicist right here. I'm not going to have him look back here at me. He's going to look at this detector. I'm going to come back here with a laser. I'm not going to tell him what color it is. I'm going to fire one photon through this diffraction grating. It's going to hit this detector. my question to him, give me the wavelength, right? He's going to look at me like I have 35 heads and write.
Sorry, I know this is an unscheduled stop, but Arwin, were you paying attention to that?
Yes, I was.
Okay, so did it make sense in terms of how the mathematics extrapolates out the wavelength? Oh, getting a bit of feedback.
Yeah. Yeah, they presumed different speeds of the light. I know.
So you've got all of these different orders of individual quanta that, can you just pause whoever's got their mic open because you're causing feedback. So whatever order you get, you can then extrapolate out from the individual quanta that hit the detector what wavelength you get. But with one, which is what John's just about to say on this presentation, you couldn't extract out that mathematical formula. You still had a detected quanta hit a plate or a sensor, but you can't extract...
a minimum required registerable amount.
We just have to have more than one single particle hit the plate to extract out the wavelength. So it's a mathematical construction that's derived from single particles hitting the plate. But when you get more than one, you can get the maths.
Hold on, that's a mathematical deduction. Because
it's not a mathematical.
John, can I just ask a question?
I have a backup reason.
I'm going to go on mute.
Before you argue,
this is whistling past the graveyard.
Look,
go ahead.
It's a minimum amount of energy required in order to register on the plate. Okay, you know this. And this is probably what they based the photon unit energy amount on. They have to register some kind of amount somewhere. That is how science works. That's how they proceed. Okay.
I don't know what you're on about. So I thought we'd gone past the bit where you were going to go and study the photoelectric effect. Now we're on to how they get the mathematics of the wave to call it a wave and have people assume that you need a medium for this wave to traverse.
No, I'm not discussing any of that. I know that the wave is an apparent effect.
That's the name of this show, Arwin. So while this might be the penny dropping moment for you and hopefully some members of the audience, yes, this is absolutely where we get the misapprehension of a wave, when in fact it's a mathematical derivative of something they have extracted given these orders that I'll now put back on screen. Let's get it back up.
Nathan, could I just ask John a quick question?
That's exactly what I said. Yeah.
Okay, Arwin, good. Glad we're all in agreement. So definitely not a wave then?
No, only an apparent wave.
An apparitional wave?
Yeah, it's a natural side effect that just suggests heavily.
Okie dokie. I think on that note we'll move on.
Rightfully so. It's a nonsensical, inane inquiry. He's not going to be able to do that, right? This is a begging the question fallacy, right? It's a convention is what it is. Now, is the convention right or wrong? I mean, no, it's the question's malformed. Conventions aren't right or wrong, they're just conventions, right? So the problem arises when you come outside the boundaries of the convention and make a statement based from the convention on reality. You can't come out here and say, the wavelength of this light is 400 nanometers, and so we're going to come out here and say, well, particles are waves. No, you can't say that. It's a begging the question fallacy. It's prima facie, right? And I already showed you with the one photon, he's not giving me any wavelength, right? It's just a convention. It's used for communication, right? If somebody says 400 nanometers, or you read it in scientific literature, 400 nanometer light, well, everyone knows that's UV light. There's no problem with that. I have no issue with it. But it's when you come outside that convention and make statements or knowledge claims about reality, you can't do that. right? We all know that. So when they manufacture a wavelength, and that's exactly what they did, well, then frequency is a cakewalk, right? Because frequency is nothing more than the speed of light over the wavelength, or lambda. Well, we already established that the wavelength, that's a begging the question fallacy convention from above. And the speed of light is also a begging the question fallacy convention. We're not going to talk about that here. Maybe in a future presentation we might get into it. But what you got here is the begging the question fallacy sandwich. That's all you got.
Sorry, did you want to add something to that, Adam?
It was just a query, really. Just maybe a point of understanding with regards to what John was saying. So just a question. So what you are saying there is that with that previous experiment, that the wavelength of light is back calculated mathematically based on the probability distribution of lots of particles, but it is impossible to calculate based on one, any wavelength, which shows it is particulate in nature as opposed to any form of wave in a medium, because the wavelength is just a mathematical presumption on the probability distribution.
Yeah. Yeah, it's based on trillions of particles that are fired through the diffraction grating versus one. That's how I showed that it's nonsensical buffoonery. Now listen, it's just a convention. The diffraction grating, interference grating, it's a convention. There's nothing wrong with it inherently, right? It's used for categorization, classification, and communication, right? That's what conventions, that's why our conventions are made. Nothing wrong with that inherently. However, when you come outside that convention to make claims from within the convention onto reality, it's a begging the question fallacy from the Black Lagoon. It's nonsensical.
Well said.
Yeah, it's not to say that it's not useful to mathematically categorize the different wavelengths, but they are an extrapolation of individual particles and how they behave. That's not to say that they are actually a wave. They're not.
Yeah,
Just
part
apparent,
of. Go ahead.
apparent waves. It fits the pattern. That doesn't mean that it is it.
Well, you'd
You
have
know?
to join the dots, though.
Nature reflects itself.
But
The
it
patterns
doesn't.
of nature
But-
reflects itself all throughout creation.
But it doesn't in this instance, Arwin. So there's no wave, none whatsoever. They do if you literally do your little drawing of the dots between where they hit individually as particles. But you drawing at the dots, that's all, pictorial for something that's a mathematical description of what's happening when individual particles strike that plate. That's where they get the convention from. So particle physics is where you get this convention that's then mathematically reified by people into light being a wave. And then when there's a problem, you get further begging the question fallacies, i.e. ether strapped on top to make that convention reified into actuality work where it should not work. That's why this nonsense is being discussed. But that was that bit that's just covered is to me that, it's the why of the reification of this mathematical construct of a wave for a particle. Do we move on, or is there anything else to add?
It's funny we're hammering this, whether they're particles or waves. It's a side point to the actual point, but that's okay.
It's an apparent wave.
That's okay. We could, like I said, I was going to get into specifically particle versus waves. It's a real short presentation, but we'll do that next week along with the rest of the presentation. How about that?
Yeah, sure. For now, we'll carry on with this.
Okay.
I mean, this is over. There's no argument against this. So like I said, the interference or diffraction pattern is birthed or governed by the wave function. But the wave function isn't real. It's only a contrived concept. That's all. Therefore, this whole exercise is only a contrived concept. You have to go back to its roots, right? It's just a convention. But like I said, I already showed you that with a photon, with a single photon. And again, like I said, this is collective particles, right? So collective particles, trillions of particles are being fired here. Contrived wave-like, right? They contrived a wavelength from this convention into reality, right? Non-duality. That's what it is. Collective particles, contrived wave-like non-duality. And let me give you the electromagnetic spectrum. Through visible light, the whole thing from radio waves, right, through gamma rays, this is all photons. There's no question here. And what are photons? Well, they're particles. It's over. To summarize, a particle is a particle and a wave is a wave. There are no wavicles or paves. There's only two ways to magically endow a particle with a wavelength, then frequency, right? And that's even inane prima facie. We only have a particle. So we have the wave function. That's Schrodinger's equation. We already talked about that. That's not a physical wave. And B, the diffraction or interference grating. This is a contrived convention because this is based on the wave function. It's over. It's over. There's no argument here. You can't even conceive of an argument against this. It's end the story. By the way, as a result of these conclusions, the 1929 Nobel Prize in Physics needs to be rescinded. I'm sorry. The one awarded to Louis de Broglie. Right? What Louis said was...
It's worth pointing that out again, John. Just debunked a Nobel Prize winner.
Yeah, the 1929 Nobel Prize in Physics went to Louis de Broglie. Yeah. What was your question?
Just pretty much debunked him, right?
Yeah. Now listen, this guy was brilliant, right? I'm going to tell you what he did. See, like I said, they had all these interference patterns, and then he figured out interference, the wave patterns. Well, photons were actually particles. So what he did was he postulated, well, if light, which we thought were waves, is actually particles, then what if what we think are particles, like electrons, neutrons, or protons, have wave-like attributes, right? That was pretty ingenious to do that. And by the way, he was a graduate student at the time also. Seems like these graduate students have a little more leash than everyone else. But anyway, that's what he postulated. So what did they do? Well, they sent electrons through the double slit. Guess what happened? They got this pattern, right? This is an interference rate to happen. The photons and the electrons acted the same way. And everything acts the same way, like I said in the beginning. But that's what they got. They sent it through a double slit. Well, this is a diffraction pattern, right? What did we talk about with this diffraction? So guess what they got? It's electron diffraction grating. That's how they pop the wavelength out for particles. Well, we already told you that this is a begging the question fallacy. Convention, it's just a convention. There's nothing wrong with that, like I said. The problem only arises when you come out of the walls of that convention and make statements based on the convention into reality. It's nonsense. Begging the question fallacy. Textbook. So I'm sorry, it's over. There's no argument against this. So, before we move on, listen. Debunking this wave-particle duality stuff has no effect whatsoever on quantum mechanics. None. Zero. So this isn't really that big of a deal. But we have to cross the I's or dot the T's. Cross the I's and dot the T's. That's what we're doing.
Okay.
Everyone get that?
Sure.
Yes.
Yep. So remember, it's not a physical. Get this wave out of your mind, because it's not a physical wave that they're talking about here. This wave is a mathematical construct. That's all it is, used to describe what's happening. That's all. It's not a physical wave. You can't put like something to measure that wave that they're talking about. You can't measure that wave.
Yeah.
There's nothing there.
It's technically a wave pattern. That doesn't mean that it is a literal wave.
It's made visible by the interference pattern. That's it,
Yeah,
basically.
it's an interference pattern that's had the dots joined up based on the order that they hit. Probability. So it's a probability distribution that's been drawn together with dots by people who've reified the mathematics that describes things as a wave. That does not in any way, shape or form make it a wave.
Hey Nathan, you know what it makes it?
Particles.
No, an aberration.
Let the penny drop after the show, Arwen. Let the penny drop later. Because otherwise you'll listen back to this and be embarrassed.
No. The wave, the apparent wave, is an aberration.
No, it's just a description.
It suggests a wave, but it isn't.
No,
Just
people
description.
It's a built-in mechanism within.
Why don't you like
the
our way of
structure
describing it,
reality
Arwen?
itself.
Why don't you like the actual facts of what it is? So it's a mathematical description. That's what it actually is. When it's called a wave in reality, that's a reification of the mathematics.
No, but it's been deduced on wave patterns, comparing it.
But there is no wave pattern. There's a probability distribution. That's different.
No, the actual thing itself is not a wave. Okay.
Yep,
but
that's the one.
It compares perfectly to wave patterns, and that's why it's been deduced that it should be a wave, because it behaves exactly like a certain wave pattern.
Well, probably
that's the trick. That's the aberration.
Sure, but I'm trying to...
a heavily suggestive thing within the structure of creation that just suggests
Arwen, you're off
there
in the
is
woods.
a wave.
Arwen, before you go off in the weeds, what we actually have is a probability distribution of quanta, particles. And then you can describe that mathematically as a wave. But you are reifying it into an actual wave if you claim light is a wave. It's not. It's particles.
I think it's beams.
Okay, yeah, again, this is precisely what we asked you not to do before the show.
Beams in a spectrum.
Okay, Arwen, we're talking about complex things that are proven and we've demonstrated them, and now you're going to go off in the weeds to confuse everyone. That's frustrating. So, Arwen, we're talking about experimentally valid facts and their descriptions for how people have become confused and reified particles into waves. Now, you want to go off in the woods and talk about beams. This is just what I said before the show that I didn't want to happen.
I'll shut up, sorry. You're right.
Thanks.
You're right.
But yeah, I'm glad the penny's dropped. They're not waves. That's mathematically describing the probability distribution that occurs when you get this diffraction. Anybody else got anything to add to that?
Yeah, what time are you at on the video? Can you pop it up so I can see it?
Yeah, we're at 32:47.
Okay. You got one more stop.
Yeah.
Before the 5-minute warning.
Let's move out of this convention and let's deal with reality. So the nature of our reality, right? So Richard Feynman again, he's pointed out that the entire mystery of quantum mechanics, well, it's in the double slit. Well, thanks a lot, Richard. I mean, that narrowed the field down for us, didn't it? What he's saying there is, let's get rid of all these lines, all this stuff back here. What he's saying here is, if you understand what's going on in this experiment, well, you understand quantum mechanics. He also said that nobody understands quantum mechanics. What? I understand this double slit experiment. I showed this to my daughter 5 years ago when she was 10. Took her about 15, 20 minutes. She got it. She was asking poignant questions about it also. So I don't know. Richard Feynman's pretty intelligent guy. I'm sure he got it. Well, see what the problem here is. Richard Feynman was what? He was a professed atheist. Now, what did I tell you in the beginning of this presentation? See, you can't understand this willfully. you cannot understand what's going on here, because if you do, then you're at odds. You're directly contradicting your worldview. Atheism, they're irreconcilable. Quantum mechanics and atheism are married bachelors. You can't do it. So what do you have to do? Well, you have to be willfully ignorant of this. He certainly understood this, without a doubt. So, like I said, let's get rid of these lines here. Let's virginize this experiment. Nothing's on this back plate back here. What quantum mechanics experiments have validated is that as soon as this photon is fired from here, right? From here to the detector, until it hits this detector, there is no photon here. You think I'm crazy? There's nothing here, folks. I'm telling you there isn't. You think I'm out of my mind? Okay. From Werner Heisenberg, the atoms or elementary particle themselves are not frigging real. They form a world of potentialities or possibilities. Now, what are we talking about here? We're talking about the wave function. Potentialities or possibilities. That's what the wave function is describing, rather than one of things or facts. From Professor Anton Zellinger, the path taken by the photon is not an element of reality. We are not allowed to talk about the photon passing through this or this slit. Neither are we allowed to say the photon passes through both slits. All this kind of language is not applicable. Right? And on a personal note, this guy right here, it's a crying shame that he hasn't been knighted with at least one Nobel Prize. By my count, it should be 3. Listen, you can't get into this genre. You can't get into quantum mechanics, especially the experiments, for 30 minutes and not run into this guy's name over and over and over again. I mean, I don't even know who number 2 is. Number 2 isn't even in the galactic vicinity. So to set the record straight, right?
Okie doke.
Got that?
So this is my cue to tell the audience. So if you want to join this discussion, there is a link. So we've got a little holding pen set up, which is currently on mute. But when the presentation ends, hopefully we'll have a few guests. If you're currently watching and you've watched from the start, just refresh your page and you'll get the link in the info box. Feel free to join. Hopefully you'll fight amongst yourselves while the presentation ends, and then we'll open the mic on... well, how can I phrase it for the audience? We'll take calls from people. There we go. But the format for joining is as it's ever been, if you're familiar with the debate. But yeah, has anybody got anything to add to that? If not, we'll move straight on.
Yeah, it's the last part too, so it's pretty short. Gets to the point.
Okay, let's stick this last bit up, and then we'll have a little bit more discussion. Then we'll open it up to the public.
So back to the double slit experiment results. So what is going on here, right? What are these results telling you? You know, the difference between these results. Now, we already talked about the particles are hitting this. That's not the issue. We're looking at the overall pattern. So what is this telling you? Well, it's telling you, let's go with the interference pattern first. It's telling you that if there was no detector here, that the photons were acting like, very important, like waves, non-physical waves. That if there was no detector here, you wouldn't get anything here. Nothing's existing here. As opposed to this pattern, you know, we have the knowledge of the which path information. Well, what's this pattern telling us? Well, that the photons acted like, you know, baseballs before the double slit, through the double slit, past the double slit, and hit the detector. They did exist. It's like taking baseballs, chalking up baseballs, you know, get a big double slit and fire 500,000 baseballs through back to the backstop, a black backstop. This is what you're going to get. I mean, a lot of people, when they look at these, they don't see, you know, the ramifications, but that's what it means.
Manage anything with Monday.com, even a controversial ad campaign. Your strategy? Get your ad banned.
And again, it's the overall pattern that's the issue here. Not that particles are hitting here. Everyone knows that there are particles hitting here. The problem, if they're Newtonian particles, and every particle is a Newtonian particle, we should only see no interference. We should only see this. But we see interference to the right. Well, that's a problem. Right? What are they when we're not looking? Or better said, knowing. That's the key. And why is it when we look or measure or to know where they are before they reach their destination, that's the photographic plate or the emulsion plate, the pattern changes and we get a standard particle pattern here to the left? Why is that? So again, this is the typical double slit over on the right-hand side. Young's typical double slit experiment. There are no slit detectors in this experiment. It's just virgin. He's going to fire a coherent light source, and he's going to get an interference pattern on this back wall. But, you know, after those experiments by Einstein and Compton and a few others, they said, well, wait a second. You know, photons are particles. Why are we getting this interference pattern back here? We shouldn't be getting that. Now I'm going to skip a lot of experiments, a lot of time here, but eventually they said, okay, there's something going on at these slits. Let's figure this out. So they put photon detectors here, right? Gathering the which path information. They were storing the information. And what happened? Excuse me. Well, the wave function collapsed. That's what they say. That's how they phrase what happened, the difference between the interference pattern and the two columns. The wave function collapsed, right? And they're saying, well, wait a second. I mean, we just put photon detectors here. Why is it changing the overall pattern? It doesn't make any sense. But it's really cool because there are only two choices left here. Why this wave function is collapsing, right? One's obvious, one's not so obvious. But the first one is, well, the photon detectors are somehow or in some way interacting with these photons coming through this through these slits and changing this pattern, right? Or number two, it's not so obvious. It's the path information. It's information. It's knowledge. It's knowing that's collapsing this pattern. So that's pretty cool. There's only two choices. We're looking at only two choices and a cause and effect relationship, right? Well, that's pretty easy now. We can test this. You know, we got this down. We can deal with this. So you had two camps. Either the photon detectors are causing wave function collapse, or knowledge of the which path information is causing wave function collapse. The only two choices. It's black or white. It's a 1 or a 0. No interpretations here. It's either this or that.
Okay, so that's pretty much the end of presentation that was done before.
Can you leave that up for a second?
Yeah, sure.
Because that's an important part right there. Those two choices.
Right. I was just about to say that, John. That's a nice way to end it. That made a lot of sense for me. That really sums it up before you go on to the others and the importance of them and the question that these ones leave.
The importance of this is it's hidden in plain sight. It's a direct proxy to the two ontological primitives. That is the only two choices for what is responsible for our existence, the universe and us. It's either nature, physical detectors, that's philosophical naturalism or realism or atheism, and consciousness, mind, intelligent agency, that's idealism. So number one is a proxy for atheism. The physical world is primary and everything else is derivative. Whereas number two is idealism, that is consciousness, intelligence is primary and everything else is derivative. So tune in next week because we're going to resolve this question.
So yeah, the second part of the presentation is on the delayed choice quantum eraser experiment. So obviously this is played out from a video that was done previously. So science versus scientism, quantum mechanics, double slit, and the quantum eraser explained. So you can check out that video if you want a heads up before next week, but obviously we'll be running it in the same format. So the link is now available if you want to refresh your page and join the panel. We've already got Brenda in the panel waiting eagerly, hopefully, to ask a concise question. But if anyone else wants to join, feel free to join the panel, and shortly we'll open the mic and get a few questions from the public. So what about the panel before we do that? Any questions, any summing up conclusions? I've got one that I'll add before the end. Well, I'll do it now. So exactly that. I'll just reiterate what John's just said. Those are the ontological primitive. That they are it in a nutshell. There they are. You can see it on screen right now. So whether or not you've got the knowledge of the witch path information, that is what's causing this wave function to collapse. That is what's causing it. So yeah, maybe that can get detailed, and then if anybody else wants to add anything, boom.
I'd like to, Nath.
Go on, Adam.
When I said John summed it up nice there was a reason, and that's that summation of the witch path bit kind of answers my question. But I did make a little note as within the description you were talking about the behavior of it, possibly like a baseball as a particle. And I was kind of supposing the question to myself, okay then, does it behave like a baseball on the whole journey, or does it only behave like a baseball as it's observed?
What journey?
But like I said,
what journey?
The ontological.
Be a bit more specific. What do you mean? What journey?
So if you're assuming that it is a particle and it's just traveling along that path, is that path at the point of observation defined all the way from start to finish because you're observing it, or is it only defined at the point of observation? So afterwards, does it carry on?
Well, there's two things. Well, first, let's cover the first, which is that it's the point of knowing as opposed to the point of observation. That's the first thing. The second thing is no. Without you knowing, it will always just be a probability laid out before you, depending on when it's fired. But it won't make any difference to what actually comes out as the end result. It'll just have a probability of which point it will hit, because you don't know which slit it's going through. So I suppose in answer to your question, the route that it's taking is kind of irrelevant if you don't know. It's just going to produce that distribution based on the probability of where it will land, and that's all you'll ever get.
Yeah, I mean, like I said, the two end choices, as I said, as John presented at the end, that's the kind of thing that answers it. It is the knowing, it's the knowledge that destroys this even just as an observed phenomena you can't comprehend. Does it just appear, etc., etc.? It's that knowledge of the path that kind of adds much more proof of the creator, or proof of programming of the creation.
Beautiful segue. So we're talking about knowledge. Well, what's the necessary antecedent for knowledge, Adam?
Well,
a knower.
Yeah, I was going to say something to actually know it is what I would say.
Precisely. So this is where it gets much more philosophical, as John put it at the beginning of the show, in terms of the implications of this scientific validity given to the knowledge of the witch path in this instance. That's your cue, John.
Yeah, I'm sorry about that. Yeah. And remember, it's only, we haven't even developed a hypothesis yet. It's in the presentation, but we haven't yet. That's for next week. So that whole section right there is going to be dealing with the delayed choice quantum eraser, the results, and the ramifications of the results for the nature of our reality.
Indeed. So tune in next week for that. But Betty, have you got anything? I'm sure you have.
Well, not really, because for me it's very clear. But the thing people are confused about is the particle bit and how can you produce a single photon and stuff. I think the most questions are more about the experiment itself than on the implications of the experiment, and I think that those questions need to be addressed also before people can finally get to the point of the whole experiment. People want to go away from what the implications are and more to the experiment itself and try to debunk it. And I wonder why that is sometimes, because if you first listen to the whole experiment and why it was set up and what the conclusions are, then for me it explains so much that time and space doesn't exist, and that there must be a knower to make matter. So for me, that the whole thing is clear, and I think that John explained it very well. But then I understand also that many people will have these questions.
Well, there's many people who are stuck whether they're particles or not. See, that's where we're stuck on. That was answered about 100 years ago, right? And I'm trying to move on to the topping of the ice cream, but I got to go back until the ice cream machine was made. It's real simple. I'm going to put it out. In fact, next week, before we start the actual experiment, we're going to end this photons or particles or not. Okay? We're going to end it once and for all.
Waves or not.
Yeah, I think that's needed, because otherwise people can't move on from this aspect to the next, because that's the bridge.
Well, we're battling our own side in that regard. There's a lot of flat earthers that think the same, that are insistent on light being a wave.
Yeah, well, the first idea was that it was a wave, and people have that in mind, and they can't get rid of it. But the whole thing about the photoelectric effect that Einstein did have correct, that he did do that in an experiment, and it proved that. I saw that in that video. I think that you posted the link in the side chat, Nathan. Did
I did, yes. So the public's got.
Yeah.
It was when we were talking about it, but yeah, I won't post it again.
Yeah.
Has anyone got a picture of a photon? That'd make it.
It's a little bit too small.
I don't have a camera that small. So
you have to be pretty fast.
Well,
Is
the closest
fantasy about?
Hold on, the closest thing you can get to it is probably watching the experimental setup in the video that's in the link. We've mentioned it a couple of times on the show. So yes, you can demonstrate it hitting a sensor, and if it was a more old-fashioned version of the same exact test, then it would be hitting a photographic plate. So yes, you can experience it. The closest I can get to it is a link in the info box, so you can see the experimental setup. And the criticism that came from the public that when that was first put in there was, well, it's showing it on a screen, and unfortunately I don't have it. Well, I just want to qualify that, because that is a criticism, and I just want to qualify it. No, I don't have an old-fashioned version where it's hitting photographic plate instead of a screen. It's a sensor like a camera, and no, unfortunately that's as good as it gets in modern nice production, as opposed to something that I simply don't have, which is the same thing hitting a photographic plate. But you don't have to do much research to know that the same thing applies with a photographic plate. Anyway, Arwin, did you have anything to add? Arwin still with us?
I don't think so. I think he
left. He did say he was going to nip off, so that's fine. In that case, I'm going to shortly open the phone lines, if you like. But before I do, I'm going to do some super chat shout out to Yuya. Thank you very much indeed. James, thank you very much indeed. Eagle Plane Nanka, really appreciate your support. 10 to the minus 17 Tor, thank you very much indeed. They lie Ohio. Doug, thank you very much indeed. Really appreciate your support also. Rune Thornton, thank you very much for super chatting. And Abraham Mohammed, thank you very much indeed. Really, really appreciate all of your support. Thank you very much. I'm sorry I didn't shout you out when you were super chatting. Okay, so from there then, let's move on. We've got with us Anon Moto and Brenda. So let's just say a quick hello to both of you two. Hello.
Good afternoon.
Good afternoon. Can you hear us, Anon?
I can. I hear you.
Quite quiet in the hangout. I'll turn you up a bit. Okay, hopefully we've got some concise questions from either or of you. Who wants to go first?
No, I don't have any questions. I don't want to be called a crayon muncher, Elmer Fudd person.
No.
I was just listening.
That's not the objective.
It's okay.
If you do have inquiries or whatever you want to phrase them, Anon, this is your time. Go right ahead.
Well, I have a dispute. I mean, because most of what you've said is just completely wrong. Quantum Eraser doesn't know what he's talking
generalized
about. He has no knowledge
hand wave dismissals are not valid arguments. So get specific or leave.
Yeah, get specific.
The fact is that we know that light propagates as a wave and then the wave function collapses when it's at the detector to a particle.
Sorry,
So you're saying that it's a physical wave?
It has a dual aspect. It behaves as both a wave and a particle. And that's just a fact of reality.
That's not a fact of reality. That's a married bachelor contradiction. And my question to you is, are you saying that this wave is a physical wave? Yes or no?
Yes. Yes.
So it's a physical wave?
Yes.
So I just went through this whole presentation and showed you why it isn't, how it isn't, and from the experts in this field that it isn't. But you say, nuh-uh. So what is your evidence that they are waves? Physical waves, please.
So the question that's being tabled, Brenda, is what is your evidence that they are physical waves, given that it's just been demonstrated that that's a mathematical extrapolation from the probability distribution of particles?
There's been numerous experimental evidence by Patrick Cole, Zudrewski, Kaneski, Stephanie Weiner. They made a breakthrough experiment at the Center for Quantum Technologies at the National University of Singapore. They found that wave particle duality is simply the uncertainty principle.
Sorry, can you repeat that, Brenda? Sorry, just let her get to the end of her statement.
Patrick Coles, Jedrzejka, it's a Polish name, I can hardly pronounce it, Kanowski, Stephanie Wehner. They are at Quantum Technologies at the National University of Singapore, and they've done experiments, doubling down that basically light is a wave, and when it is detected, it collapses to a particle.
Okay, so do you have the name of the experiment?
No.
Brenda, can I ask you a question with regards to that? If it is a wave, as John was showing in the presentation, what is it a wave in?
It has dual properties of being both a particle and a wave.
That's not what he asked.
No. Sorry. What is the wave
it's
occurring?
The ether, the medium? E word, the ether.
Yeah,
word.
there's no ether. There's no ether.
Hold on. Hold on. Let me get control. I don't want this to get out of control quickly. Bear with me. So, just before, Brenda, the question that's being tabled to you, and if you don't have an answer or whatever, we'll move over to Anon. But what is the medium that the wave is propagating through?
Photons don't have a medium.
So how can it be a wave?
I don't know. It just is that way.
Okay, thank you very much, Brenda. Your input's been really appreciated.
Just is. Well,
Brenda, thank you. Really, Brenda, thank you. Really appreciate it.
Yeah, you can find a physicist.
Brenda, Brenda, I don't want to have to kick you out. Thank you, Brenda. So, Anon, I know you had something to add to that. And hello, 10th man, we will get to you.
Hey, yeah, I know the E word, the ether word, is a big no-no in the quantum world and the Einsteinian relativity world. So you're not supposed to use the E word. So what the quantum mechanics people use,
breaking up a little bit.
I forget what it's called.
They
have a name. They have a name for the ether. They renamed it to a quantum foam. That's what they called it. The quantum foam is what they call the ether, because they can't use the ether word. So there still is something that requires wave, and that is the ether. You want to call it inertia, you want to call it quantum foam, you can call it whatever you want. There's something that waves. So there you go.
The quantum foam has nothing
to do with
Brenda,
bear with me. Brenda, sorry, Anon.
He's wrong.
Brenda, I'm not asking you to debate the... Okay, I'm going to have to remove you. Thank you for your input, Brenda. It's been really appreciated. So, Anon, you're saying there's a medium called quantum foam. Is that correct? Is that your assertion?
No, that's not my assertion. The assertion, the quantum mechanics people call the medium that they have to call for when there's nothing else, but there's something waving. So, that field they call it quantum foam. I'm on my phone and I have 2 kids here, so it's hard for me to pull it up, but you're more than welcome to pull up quantum foam.
Sure. Is there an same question as I gave Brenda then? Is there an experiment that you can take us to, or is it just the declaration of these so-called quantum mechanics scientists?
The quantum foam thing.
Brenda, I gave you a hint that I was going to kick you out. Now I will kick you out. Goodbye, Brenda. Sorry, Anon. Carry on.
The quantum foam is what they declare as whatever the medium is, because they can't use the ether word. So that's what that is.
When you say
just look up.
When I said is it experimentally valid, or is it a declaration by a man or a woman?
Well, I mean that's on the eye of beholder, because like for you believe that the quantum eraser is an experiment. I don't believe that's an experiment, and I learned it from you guys and John himself.
Anon. You brought up quantum foam, and I'm asking if what you claim is the medium that is necessitated for light to be a wave, is that experimentally valid?
I don't consider any of this experimentally valid.
That's not my question.
Yeah, they claim it's an experiment. So if you look up quantum foam, they claim it's an experiment.
So it's called
let's do it.
Okay. It's called the quantum foam experiment?
There's a paper called that talks about the quantum.
Sure.
No.
So not an experiment.
Just look up quantum foam.
But is it? You're saying it is an experiment? This is the detail that we need.
I know that they call ether a quantum foam. Now, as far as how they obtain it, or is it just like a deduction reason experiment? I don't know. I can come up tomorrow and get more data, but right now, like I said, I'm on my phone.
That's fine. It's been thrown out there. We've heard the words. Maybe people in the audience will go and Google it. Hopefully, you'll come back to us with experimental data such as observed natural phenomena, presume cause.
Yeah, because when it comes to experiment, I would have to, I learned most of the stuff from you guys. So I don't like, for example, the quantum eraser experiment. How is that? The first step is, as you say.
Well, in that case, Anon,
where's the natural?
We're going to cover that next week. So, in that respect, great. If next week, literally this time next week, we'll do exactly the same process. If you want to come back on with experimental data for the quantum foam and a debunking for the most definitely experimentally valid delayed choice quantum eraser, that's when we'll be covering that, because at this point we've just covered wave, particle, duality, and people's apprehensions about it being a particle and actually being a wave, when in fact it is definitely a particle, and the probability distribution that is created by those particles is mathematically described as a wave and then reified. The further reification of a medium is also required when that fails. But if you're saying, no, the medium needed to reify this mathematical description has been experimentally valid, quantum foam is the validation, then just bring that next week, and we'll also talk about the delayed choice quantum eraser, which you're welcome to challenge also, but just then rather than now, if that makes sense. Is there anything else on? If not, I'll ask 10th man for his input.
Nope, go ahead.
Well, before I do 10th man, sorry to be so rude, anybody else on the BALLBUSTERS panel that wants to address, because I'm taking the lead when I shouldn't really be. It's very rude.
No. You're doing a great job with it, and like I said, we'll get bogged down with particles versus waves. Listen, if anyone thinks that these are physical waves, this is what you're going to have to do. You're going to have to debunk the photoelectric effect in 1921. Then after that, you're going to have to debunk the Compton scattering experiment in 1922. Then you're going to have to debunk Heisenberg's uncertainty principle. Okay? So best wishes for that. I'll wait for that next week. Thanks.
I was going to say, you don't necessarily need to have photon in order to have the photoelectric effect. You can still have that with waves. So that's not necessarily...
You can't. You can't, the photoelectric effect, you can't do it with waves. That's already been disproven. If we want to give him the video, I seen that video pop up. So he can educate himself, because you're just talking nonsense.
Well, okay. Either way, we've got another panel member, so I don't know if you can hear us, 10th man, but I'm hoping you've got a concise question or something that you want to add to the panel.
Yes, can you hear me?
I'll level you up a bit, but yeah, go ahead.
Here, I can turn up my volume. Tell me when it's better.
You're good.
Hello?
Yeah, go ahead.
Okay. I think I'm going to have to wait till next week to get the rest of it, but my question is, can we get a summary of what Quantum Eraser is actually saying in 1 or 2 or 3 sentences? Because I have some questions, but I'm not fully understanding it personally. So if you can summarize it, and then if I have that question, I will ask it. If not, I'll wait till next week.
Could I take that? No.
Go ahead.
Yeah, go ahead, Adam.
John's not saying anything. It's the implications of the experiments you've just seen.
Yeah. Go on, Adam. Sorry.
Yeah, I don't get why it has the strap line John.
Well, it's just because he's made the presentation. I mean,
Yeah.
maybe John will add to this, but if I gave a concise explanation, it would be to say that the probability distribution created by the particles, and as we see that effect on either a sensor or a photographic plate, is then mathematically described as a wave. And that mathematical description doesn't mean that individual quanta hitting photographic plates or sensors are waves. They are not. That's the concise explanation of what we've just, or what John, more precisely, has demonstrated quite admirably. So I'll just repeat it. You have individual particles that are hitting a plate in the examples used in this presentation. Now, if you have multiples thereof, you can have attributed to that a probability distribution. And that probability distribution can be described mathematically as a wave. However, you are still only observing particles and not a wave. That's it.
Yeah, but that's just a part of the whole thing. We also have the clump pattern, 2 stripes at the back of the end of the detector. Because if we watch or detect or see what goes through the slit, then the pattern is different. And that's the key point, is that when we observe it, the pattern is different than when we don't observe it. And then we get that interference pattern, which we call so-called a wave. And I don't think that we have to lose sight of that as well, because that's the double slit thing. That's important. We need to see that there is a difference between observing it and knowing the path and not knowing the path.
Precisely.
Okay, for his question, maybe he was just asking, what's the point? Can I summarize that? Can I ask him? Can he hear me?
I can hear you. While we're answering the question, because there's obviously people joining and leaving and stuff. I've got the Hangout closed down, but they can hear you.
Okay, yeah, I think his point was, well, what's my point? Right? My point is that we're trying to discover the nature of our reality. And what it seems to be boiling down, and I'm using seems, I shouldn't say seems anymore, because it's really actually over. Our reality is based on information. Information and free will. That's what our reality is based on now. To have information, that's a consequent. The necessary antecedent is a knower. So that is the point of this experiment. Matter does not exist without a knower first. That is the whole point. That's why I'm here. We're getting bogged down with photons as particles or waves. That's not the point. All this is just weaseled obfuscation to me. The point is, matter does not exist without a knower first. Thanks.
Okay, we've also been joined by Ali, so hopefully I'll just get a quick nod from 10th Man that's answered his question, and he's hopefully got a supplementary question off the back of that.
I'm trying to get my supplementary, but I keep being interrupted. But John explained it perfectly there. So my question, now that I understand the summary, is the relationship that he just talked about, the knower and the registering or the realization, if he can connect that a bit more tighter, because I get it now.
I don't know how I can get any more tighter. I'm not following your question. Can you rephrase?
Animals observers.
Sorry.
Please let me talk.
Hold on. Can you rephrase your question, please, 10th Man?
I'll try if I'm not interrupted. Thank you. So I'm getting what John just said. It was very good. I'm getting what Nathan said as a summary. Very good. And because I'm not familiar with the subjects, but I have a handle on it now, I need to get a little bit more for my mind to grasp it. So the knower and reality and the double slit experiment and the realization of what it actually does versus the probability of the mathematical. If we can condense that down for a farmer, I would appreciate it.
Oh, right. I think I see where you're going. But if you listen to the last part of the presentation, that was if you can go back after we're done here, go back to the presentation to where we stopped. And I left the two questions out there for the difference between the interference and the clump pattern. That means that particles are acting like waves. On the other hand, they're not in the clump pattern. And there's two choices there. And we stopped there because we figured it would take too long to go through the entire presentation. We stopped there, but those are the two questions. Now, I haven't formulated the hypothesis yet. Don't watch the original presentation because I did and went through everything. But for our purposes here, for the next show, that's when I'll go ahead and go through the scientific method, and we're going to find out, we're going to adjudicate between those two questions.
Well, I'm going to tie it to it now. Sorry, John, if this is stealing your thunder. Just remind the audience, what are the two ontological primitives, please?
The two ontological primitives are nature created us. That is the basis of philosophical naturalism, realism, atheism, versus an intelligent agent that is consciousness, that is knowledge, that information. So that's idealism. Basically, it's a battle between two philosophies, if you want to boil it right down to it. Atheism versus idealism. There's only two ontological primitives, and that's what they are.
Okay, and without giving the game away too much, and what are the two choices with your double slit and the detector, the thing that gives you the knowledge?
Yeah, nature is the detector part. That means physical nature. And the second choice is knowledge. So there's atheism and idealism in a microcosm.
You know, on the screen right now, Nathan, you've got the matrix code running down. And the way I kind of view this is you can create a code for the universe, DNA, whatever, and nature could randomly generate that. But who created the meaning for that code is how I view that ontological thing. I think
exactly.
You got it. How would the code come into existence? Because if the code, let's pretend for a moment that the code is information. Yeah?
Yeah.
Well, I asked you the same question earlier. What's the necessary antecedent?
And that's programming.
Yeah, and there's another issue.
A programmer.
Because there's one more issue that we sidestepped here. What is information?
It's all gone quiet over here now.
Yeah, it's gonna get...
Well, it's because we're leading into next week. We want to keep a certain amount of cliffhanger element to this because there's certain aspects that we knew this was. I mean, it's already on to what we're up to. 2 hours of show, and if we'd have done the full presentation with the delayed choice quantum eraser and not just hinted at the ontological primitives, this would be 4 hours. But we've also got another guest, so I'm quite conscious that Ali B's not had an opportunity to actually ask any questions. But before Ali B does, is there anything you want to add to that 10th man? I hope your questions have been answered.
I do want to add, but I think that was a breakthrough on the last one when you identified the plate as nature and the knowledge part. That I'm going to listen again, but that opened up my brain a little bit. But the question
that's the point.
Now
yeah,
remember, hold on a second though. Don't get confused, and I'll explain this next week in the presentation. When I'm talking detectors, I'm talking about slit detectors. I'm not talking about the back screen detectors. Those are just catcher's mitts. I'm not talking about those detectors.
I got you.
Okay.
I got you.
Okay.
So the question is, to question hopefully my last question is, how do you relate this to cause and effect?
How do I relate it to cause and effect?
Can I take that?
Yeah, go ahead.
The cause in the experiment is the knowledge itself. The understanding is the cause of your collapse into those 2 bars, if you like. So before you have that, without the knowledge, you have just a probability distribution. That's all you have. But with the knowledge, you cause the wave function to collapse. The mathematical, just before anybody writes bloody comment. Yeah. So that's what's causing it. And as John's just pointed out, what gives you the knowledge? Well, actually having a detector at the slit so you know which one it's gone through gives you that knowledge. But knowing is ultimately the cause. Does that make sense?
Okay. So basically, he's saying either by design or by chance.
No, it's either. I guess you can boil down if you want to talk about nature as by chance. I don't know, that's a little squirrely to me.
I think you're confusing it a bit at the moment. For what's been presented so far, it's just sufficient to know that the detector means you know. Don't disseminate go into the next bit, because for now it's just knowing which slit it goes through. So it's the knowledge. It's fine for now not to necessarily critique the experiment itself and develop it.
Yeah, because don't associate the physical detector with knowing, because you can have a physical detector there, right, at the slits, and have it not connected to anything, so you don't know anything, right? It's just a detector. It's detecting on an empty tape.
Oh, we're getting into the weeds a little bit here, because we're going to get into do you have the possibility of knowledge? You've given me this example in the other presentation we did on this subject, where you talked about a computer that's hooked up and then it gets burnt down, and what do you know? You've ended up with an interference pattern because you never had the opportunity to get the knowledge. So, you know, we're going to go into the weeds if we cover this, and I'm sure we will definitely cover it next week. But right. Again, hopefully we've got Ali B hovering over his mic, and he's hopefully got a question as well. Are you there, Ali? Can you hear us?
Yep, I'm here, Nathan. How you doing?
Mike's all yours. Go ahead.
All right, it was just to ask Quantum Eraser. Do you know when you fire off the detector, yeah, what happens if you don't detect the whatever it is, the proton that you're firing, whatever you're using to fire through the slit? What happens if you don't detect it? What do you assume from that?
Well, you could do it a number of different ways. You could put 2 photon detectors, or whatever you're using. You could put either 2 photon detectors, or you could put 1, right? That's one of the most amazing things too, because you can get the clump pattern just with 1 detector. Because if you fire a photon or whatever, and it goes through the detector that's not detecting, or it goes through the slit that's not detecting, then if you don't detect it with the detector at the first slit, then you ipso facto know that it went through the other slit, and you get the same pattern. So all you need is 1 detector. You see how that goes?
Yeah, I'll clarify that again. So when we're talking about, this did just come up, but when we say detector, we're talking about specifically slit detectors. So what John's just boiled down is if you've got a slit detector on both slits, it makes absolutely sod all difference if you've got a slit detector on one slit, because you fire a quanta through, and if it doesn't go through one, in other words, the one without a detector, then the detector that was on didn't see it, and you automatically know it's gone through the other one, and vice versa. If it goes through the one with a detector, obviously you've detected it, and therefore you know it's gone through that one. So it doesn't make any difference if you have one or two detectors at the slit, because there's two very specific types of detector. One is going to be the photographic plate or the sensor, and the other is going to be the actual the addition of an extra detector at the slit itself to cause the mathematical wave function collapse. So that's the detector we're talking about. But the point John's making is you don't need two, you just need one. And once you've got one, you'll know ipso facto whether it went through the other one, because it's either detected or not on the one you've got a detector on.
And if you tune in next week, you're going to realize that doesn't even matter, but we don't want to give the game away just yet.
About Betty, Adam, Brad?
I didn't know whether Ali meant there maybe in a more quantum sense, that how do you know if it doesn't go through the first? You have this physical presumption it's going through the second gate. Actually, in a quantum sense, is that real unless you define it? And maybe it doesn't go through any gate and just pisses off the other side of the universe. I didn't know if you meant that sort of concept.
Oh, well, that would be a bit of confusion then, because if you... I don't think that's ever happened. John, you'll have to tell me. Has there ever been a case that you fired...
I'm lost.
Yeah, what I think is being said is you fire off one particle and it goes through the slit and isn't detected on the photographic plate. In other words, it just disappears. But I don't think that's ever happened, right?
Well, that was my point, because the statement was, if it doesn't go through one, where does it go? That's what I meant, whether it was meaning a bit more in a quantum sense. Is there another path it could take in a quantum sense?
Yeah, I'm a little bit lost on that one. Maybe
I'm
you're
a
going to
bit
have to
too.
get with me after the show. I'm not following.
My basic understanding of quantum mechanics, John, is I don't understand it.
Me neither, Adam. We're in the same boat here. My knowledge is extremely limited. Thank God for John.
Now, did I answer the? Check and see if the question was answered. Maybe I missed.
There's quite a lot of conversation going on in the Hangout. I'll see if I can get the Hangout's attention. Hello, Hangout. Can I get your attention? Did your question get answered, Ali?
Oh, can you hear me?
We can.
Oh, right. No, it never. Because what you told me was, right, and the thing is, it's so funny how you're so strict on assumptions and stuff like that. Because we couldn't detect it there, it went through the other one.
This is what I was saying.
Did you get that?
So, Ali, expand on that, because I've just fought your cause in trying to expand on that.
No, I've been muted. I've been muted for the last 10 minutes. I've been talking to Anon for the last 5 minutes saying how funny it is we're muted. No, my question never got answered. I was asking the question.
You see,
right. So therefore, right, okay.
Balance.
I said, what happens if it doesn't get detected through the one detector? And Nathan said, oh, well, if it doesn't, Quantum Eraser started going on about two detectors and all this kind of shit. And then Nathan explained very, very nicely, mainstream media, about what quantum physics is. But the point I want to make is that if you don't see it with the first detector, you automatically assumptions. I thought we don't do assumptions in the flat earth, but obviously we pick and choose.
What world are you talking about?
So, did you?
You know what I'm talking about. You're assuming. I asked a question, a very good question.
No, I see your point now.
What happens? I asked. Wait a minute. I asked a question. What happens if it doesn't come up in the first detector? You said we could automatically assume it goes through the second split because.
I see your point now, Ali. Sorry, my bad. So what you're saying is, if you've got one slit detector and it's not detected on that slit detector, I'm automatically, and I did very specifically say that, assuming it goes through the second slit.
Yeah, we're assuming it hits the back plate.
Yeah, that's the catch, Smith. You can count those dots on the back slit, and
Yeah.
you know how much you have fired.
Yeah,
And if you
Allie.
don't detect it on one slit, then it must have gone through the other. That's the
And
whole
if
thing.
there's no particles detected on the back, then it didn't go through either slit.
Yeah, we did cover this. We did cover this. So I said, ultimately speaking, because Adam qualified it, because that would mean or imply that it wasn't detected on the photographic or the plate. You're not seeing anything hit. In other words, if it goes through one slit with the detector, yes, obviously, Ali, I appreciate what you're saying. It gets detected, and that's obvious. But then if it goes through the other slit, you're saying, well, how the hell would you know it's actually gone through that slit? Well, it gets detected on the other side, so there's an impact.
No, it doesn't, because there's not a detector there.
Yeah, there is. The photographic plate is the detector, so I qualified that as well. So there's two different types of detector. Slit detector, and the plate at the back is also a detector. It detects that a particle's actually hit it. So if it's gone through the slit that's not got a sensor on it, and it hits the back, then it ipso facto has gone through the slit without the detector. It hasn't, like Adam put, it hasn't just disappeared into random nothingness in the universe because it's been detected at point 2.
That's the point I wanted clarification on. If you are getting a strike on the plate at the back, then fine, you can. I think it's reasonable to assume you've gone through the second slit without a detector there to confirm it. I was asking, how do you assume it goes? Where does it go if you're not? There wasn't the previous statement of you getting the detection. So my wandering off into conjecture is negated by the fact that you say there is a strike on the other. It's reasonable to assume if it's not detected on one, then it has to have gone through 2 or magically wiggled its way through the plate.
Yeah, to be detected, it had to go through one or other slit. Either it was detected when it went through the detectable slit with a detector on it, or it went through the other slit. There is no third choice as far as I'm aware. I mean, I don't know, is there a third choice?
This is the point in quantum mechanics. Apparently there is. That's what always scares me with it. You know what I mean? You brace for impact for the third quantum choice sometimes, because it is confusing to me. So,
well, if it didn't hit the back plate, then it didn't go through either. Sorry.
Yeah, but that's the point, isn't
Sorry
it? It
to
did.
be
We're getting a detection on the back plate.
Is that sarcasm? I didn't.
Oh, right. My bad. Sorry, I didn't detect the sarcasm through the American accent, maybe. Yes, exactly, John. Right, okay. So if the Hangout can hear me, Ali, can you hear me? Hopefully you can. Probably not. They've been talking the entire time while we've been discussing this matter, moaning about being muted like they're actually part of the show rather than calling in. Anyway, right, so yeah, okay. So yeah, I'm not going to be able to get an opportunity. The Hangouts just literally rumpusing themselves. So anything else that the actual BALLBUSTERS team wants to add to this? Not, we're going to round out.
Yep.
I've got one last question.
Whirlpools.
It's a bit whirlpool.
Whirlpools.
It's a little bit whirlpooly. So you send that photon off on its little, and off it goes. Now, if we were to able to assess its position at every point on its path to the sensor, would its path be a linear function, or would it be in any way wavy? Or is the simple, well, I'll leave it there otherwise.
Wavy? You mean the path it takes? The actual path it travels?
Is there any, so is there any variance? Is its path solely defined by from the point of leaving to the point of being measured? Is that whole path defined, or is there variance in the route path up until the point of being defined?
This goes back to Heisenberg's uncertainty principle.
Yeah.
As soon as you get too tight on where the position actually is, then it's its momentum is going to change in accordance with the proportion. You know, the change in x, change in p is greater than or equal to h bar over 2. We can dismiss the 2, but like I said, the moment you try to pinpoint that particle where it is, it's going to start getting uncertainty in the momentum.
Right. So,
and that's the y momentum.
So this is the next point then. At the point, if you were to say measure that a third of the way, to therefore define almost a route path, would the uncertainty then restart again from the point of last measurement to the next point of measurement? So
yes, because you got a double slit coming up, right? Yep, it's going to. Yep, it definitely will. Yeah, because you got a choice constraint there. This is really wild. In quantum mechanics, everything depends on the question that you're asking, which is really atheist. This is another torpedo in your boat. Just grasp this. Everything is contingent on the question that you're asking. So it's based on context. How in the world can something outside of your skull cap be influenced on something by something inside your skull cap? That means you're asking a question. How can that be? How can that be? It should be completely independent. Nature should be completely independent of your skull, of what's inside your skull cap, correct? Makes perfect sense. It should be. It's not. The question is the most important part of this. What is your question to nature? Now, nature's going to give you an answer back, but it depends on the context. This is repeated over and over and over in the literature, right? So I just wanted to share that with you. I don't know if that answered your question, Adam. Did it?
Yeah, totally. Yeah. Hope my analogy.
No, it was a good question. It's a good question because there's another choice constraint coming up. It's the double slit, right?
Yeah.
So I know at the end of the last show we did, BALLBUSTERS last week, we said that we'd open up the panel to questions about gas pressure. So we've been going a little bit less time than I anticipated. I thought we'd be at this point at about 3 hours. 2 hours 45, 3 hours, and we're actually at 2 hours 20. So if you guys are happy for that, I'm happy to open up the panel for the exact same thing. So if you want to join the panel and ask questions specifically about last week's topic, which was gas pressure, then you're welcome to do so now. The link is in the info box. If you've been watching from the beginning, they may have to refresh the page just to get the link. So while that's going on, again, we've got a couple of panel members anyway, so hopefully you can hear me. I'll just go and check if they're talking amongst themselves. If you can hear me on the panel, if either of you two, 10th Man or a non-moto, have got any questions about last week's subject, which was gas pressure being maintained without a container, second law of thermodynamics violations, anything of that nature, now's your opportunity.
Oh, I'm pretty clear on that. I have no questions on that. So,
10th Man?
My question is, what that I didn't get asked about the quantum thing is like, when we talk about observer, what constitutes an observer? Is a dolphin an observer? If you put a goldfish, because it's observing, is it observing? If a tree falls in the wood and there's no observer, does it make a sound? It's kind of those kinds of things. So
no,
what constitutes an observer?
Yeah, that's a good question. Very good question, Anon.
What constitutes an observer?
What constitutes an observer? Good question.
A knower.
So yeah,
a knower.
Again, this got qualified throughout the show, and I even corrected some of the BALLBUSTERS team about it, because it's not just observation; it's the actual knowledge. And that's why I was asking Adam, well, what's the necessary antecedent to have that knowledge? Well, a knower. Well, to the first part of your question was, is a dolphin capable? I don't know the answer to that, because I can't communicate with the dolphin to establish if I gave him the information of which slit it passed through. Would he comprehend it to the point where he understood it and caused wave function collapse? Well, I don't know, but it's a pretty good question.
Why can't I talk?
Yeah, it's a good question. It's a really good question. I've thought about this many times.
You can train dolphins to do all kinds of things. If you have a photographic plate that lights up with a specific color, you can train a dolphin. How about a chimp? You can train a chimp all kinds of things. Look at Coco. Coco can do all shit. She could even spell things. So if you have a gorilla and a photographic plate, is that a knower? Does that constitute a knower? Does that constitute an observer?
It's a kind of question that I'm going to struggle to answer because I can't communicate with the dolphin or the chimp to establish if they actually comprehended when I said, look, this slit detector said it did or didn't go through the slit after the photographic plate detected a hit. I don't know if a chimp could understand that, you know, but it is an interesting question.
John, can I ask you a question?
Well, let's get a dumb animal on the panel.
Well, you've got one. Here you go. Is there not some stuff in terms of knowledge of the path where at the time of the experiment, the experimenters per se don't know that it is historically set up, so it'll be recorded and you get the same result? So that are there not things that kind of take it outside of the individual per se, whether that's a human being or a sentient animal, that it's just the simple fact that the path is knowable as opposed to it being specifically known by any one individual at that moment?
No. So I didn't think we'd get into this in the show, but as you've asked, I think it's only appropriate. So, John, can you go through the example? I'm just not I couldn't do it as well as you. So, you've got the example where somebody's linked up the slit detector to a computer that's registering it, and then there's a fire. Can you just go through that example?
Oh yeah, the last part of it. So he wants to get into the other show because he's going on vacation, right?
Yeah, I know, but it's still a good explanation to answer
the point of whether it's an animal or a human, or from an experimental point of view.
No, it's a really good question. I've thought about those questions about animals. We could never know, right?
Well, that doesn't matter anyway.
Right. Where'd you get the animal?
It doesn't matter anyway. This is just an experiment for us to view how it works. But we have consciousness, and animals are conscious, so they create their matter and their experiences with their consciousness. So it's the same way, I think. So I don't see the problem in sentience and conscious beings.
Yeah, I think you still want me to go through that that one issue that we had, like the guy's running the experiment 499 times in his lab, right? And he's got 2 detectors there, and it's going to a computer within the lab. So all the path information is routed into and he's running the experiment. All the path information is routed into the computer, that the information is existing. Every time he runs that experiment, he's going to get wave function collapse 2 columns. So let's say he goes, okay, I'm going to run this 500 times, but I want to take a vacation. So I'm going to run it anyway. I could just fire and forget this thing. But instead of having the path information routed to that computer in his lab, he routes it over to the administrative building. Okay. And he puts a new plate on. The detectors are good. And he's going to fire this experiment up. He's off to Jamaica or somewhere. And so he fires the experiment up. He closes the door, locks the door. No one can go into the lab. And he goes on vacation for 2 weeks. Now, during that 2 weeks, the light source either burns out or it's on a timer. And 2 weeks after he's left, he's partying in Jamaica, the experiment ends. And now, 3rd week, he comes back. But on the plane ride back, he gets a call from the secretary, and his secretary says, well, the administrative building's on fire. So he gets off the plane, runs over to the administrative building, and the administrative building is totaled. That means all the path information that he was getting from his experiment a week ago, that ended a week ago, was in the computer. It existed, but now it doesn't exist. It's irretrievable. No one looked at that path information. It's done for. So he says, no problem. I've done this experiment 499 times. I know when I walk over to the lab I know what I'm going to get because I'm going to get 2 columns behind that double slit because that's what I got 499 times. Nothing really has changed all that much, right? But when he goes over and opens up that door, he's going to get an interference pattern because that information was not registered. No information in this reality exists on where those photons were. It did exist, but it doesn't exist now. No one knows. No one knew. That's it. It's interference pattern. Game over.
What, I just want to make one small correction. No, the information didn't exist because at no point was there the necessary antecedent of a knower. And the computer, having the information stored on it, isn't a knower. It isn't somebody actually knowing which path it passed through.
I got you. However, but that detector and the computer line and the computer putting it into English was programmed by a knower. But I see where you're going here. Let me
at no
think
stage,
about that.
even though the computer registered the data, in the same way as you could say that the detector itself, let's say it's like unplugging the detector from the computer in the first instance. Yeah, the camera looks at which path, but no one's capable of knowing it, and no one does know it. Therefore, you get an interference pattern. Well, even though the computer was wired, and you could go into the paradoxical nature of, well, when it's Schrodinger's cat, isn't it? So when the person was on the plane on the vacation and it was only going to the computer, was there a diffraction pattern? Or was your 2 bars being put onto the photographic film? Well, you can never know. It's like the cat in the fridge, isn't it? You don't know. But what he does know is when he gets back and the information was never known, he gets his interference pattern.
You're going to have a problem. Okay, let's do this scenario. That when he locked that door and he went on vacation, well, it just turns out that one of the custodians had the key. Now, the experiment still run. It doesn't have to be running. It could still be running or not. That path information is over in the physicist's office, and it exists in this reality. If that custodian opens that door and looks at that plate, it's collapsed.
That was what I was going to ask next. That's the I don't ever remember because I kind of quit A-level physics after the first year, but I know the second years we weren't allowed in a room at certain times for certain things in terms of that experiment when they were testing it, John. And that was my other question then, which relates to the animals. If in that room, right, you've seen that film Ratatouille, where the rat can cook. Imagine if he's gone in there and he's been watching it for a few weeks, so he understands what's going off on the screen. If the rat sees the screen, does that define the path?
Yeah, but he doesn't know the path, right? He just sees the catcher's.
He's Flipper. He's Flipper. He's Lassie. Lassie gets in.
Oh my God, we're off the rails, Nathan.
Well, hold on. We've got one person in. I've been keeping a close eye on the chat. Yeah. And Paula.
Hold on a second, though, Nathan. Did you understand what I just said before about as long as that path information is existing and it's retrievable by somebody that's conscious, it's still collapsed?
Yeah, of course. But the only ambiguity comes during the moment between it being locked and when he comes back, because at that point, pre-fire, it's being logged and registered, but there's still nobody seeing it. But when the fire occurs, that information is lost. So there was never in between him unlocking the door and looking at the diffraction pattern, and him locking the door, there was never ever a knower in that.
I'm tracking where you're going. It's a Schrodinger's cat ordeal.
Exactly. So you can't open the door to figure out when the information was possibly retrievable, as you're putting it. Then were you getting a diffraction pattern? Well, you'd open the door and you'd know, wouldn't you? So it's Schrodinger's cat.
You're tripping out. This will send you tripping out, man, because it has the capacity. Now you'd think that the experiment's running, right? And you're nowhere to be found. But you know that if it's real, then we got to define real, that something's got to be hitting the back plate while you're gone, right? but actually it's not. It's not happening. It's a Schrodinger's cat ordeal, right?
Yeah.
And that will send you off the reservation because then it can load up a back history. That's another thing. It can load up a back history after everything's said and done. You know, when it's already accomplished, remember what he said? When it's already accomplished most of its doing, it can change. It'll send you off the reservation thinking about this stuff, man. There's so many scenarios.
Trippy, John, already, mate. Because I'm kind of forget this quantum. I'm kind of wondering whether we've developed a test as to whether animals have consciousness. Because
Anon's question was profound, wasn't it?
Precursor with regards to their understanding of what they're seeing. Surely that would.
Well, I know my cat. He runs around here. He knows he's winding his way around here. He's jumping around everywhere, right?
John, a quick question then. Within these quantum tests that they've done, have they ever put like a child in there that has no comprehension of the significance of what the lights mean and what the outcome of that is?
I don't know, Adam. I haven't seen one.
I should be employed.
These are good questions, though. I mean, I've got to give a big credit to Anon. That question was profound.
Yeah.
No, it's a good question. I've thought about it many times, and this question, it's brought up in the literature also. This isn't a new question, right?
Take the glory away, sod it.
No, they've talked about it, man, and I just sit there and say, wow, we're really headed down the path here. It's great questions, there's no doubt about it.
Paula asked a question from the chat, and after she did ask her to join, and she hasn't, but I'm not going to repeat her question because it's slightly more relevant on the next show, like many of the questions we've had here. But ultimately, if she did, I was hoping she'd ask it on this one as well, because it was another superb question. I'll give her a nod so that she can ask it again if she doesn't join. But as I say,
she may not want to get assaulted in the holding pen next week. So
there's nobody in there at the moment. There's nobody in there at the moment. So there's nobody in the holding pen at the moment. So, as I say, Paula, you had an excellent question that I saw scroll by. As I say, I'm not going to steal your thunder. But yeah, here we go. Is that you, Paula?
Hello,
Paula. Can you remember which question? Paula. Can you remember which question, without me leading you too much?
Yeah, it was. I want to make sure, first of all, I'm hearing what you're saying, because it sounds like you're saying that the observer is the cause. Is that accurate?
Yeah, this is the question. Well done.
Is the observer the cause? And like I said, with the observers, it's knowledge of the witch path information. So you can observe something, right, till the cows come. We can all be in a lab and watching the double slit experiment, but we don't have any path information. So it's going to give us an interference pattern. It's going to act wave-like. So the point is that it's not the observer directly. And the observer doesn't, even when we do this next week, there's no observers in this experiment whatsoever in the delayed choice quantum eraser. So observers are completely irrelevant. They're out of it. The knowledge of the witch path information is inside the experimental setup. And I know I'm going to go through this experiment now, and I'm not going to do it.
Only when the observer observes that.
Hard for me to follow, because it did seem like that was the conclusion drawn, which would mean that the scientific method is impossible if that were true, because observing cannot interfere. It just can't directly or indirectly interfere, or it's not the scientific method, because then you have to determine a cause and effect. So you can't be the cause, even indirectly, or you're messing up the experiment. That just
that's what I'm saying. That's exactly what I'm saying. So it's not the observer directly. It's information. It's knowing.
Yeah, the cause isn't observing. It's knowledge of the witch path. That is the cause. The knowledge, not the observation.
Right.
Hopefully that's a bit clearer, Paula.
If you, like I said, this goes back to the Heisenberg uncertainty principle. If you want to try it like they do it with the single slit, if you try to pinpoint that exact position of that particle, it's going to do the whirly whoop on you. So
A magical property that can affect something just by knowing it and having a thought in your head? Is that what you're saying?
Listen, let me tell you something. This, I don't want to, we're going to go over this next week. It's going to come down to a point, and I'm going to have you stop at this point next week, Nathan. There's going to be a statement made. I'm going to stick on the statement because the first time I did the presentation, I didn't stick there. I spent a little time there, but not all that much, but I'm sticking there. And I think that it'll answer Paula's question on I'm hoping it will. So we'll see.
We've also got another guest. So before we move on to Kim, was there anything else, Paula? If not, thank you very much. Your question was excellent.
No, not really. I guess I have to wait a week. I'll try to remember, but...
Okay.
No, write it down. Let's write that thing down.
Oh, okay, man.
We've also got Kim.
Oh, man. So no, type it.
The table is still open for the last week's question.
Type it in Discord, then we know it too.
Hey, it's great. It's
great. That's a good idea.
Hey, guys. It's Kim here.
Hello, Kim. Very pleased to have you.
Yeah, I'd like.
Is this is this Yunhu Kim from the Delayed Choice Quantum Eraser?
Kim Long Jong, right there.
Oh,
you guys ever
watch?
You ever watch Team America? Team America.
Indeed. Did you have a question?
Okay. Yeah, I'd like to discuss this 23.5 degree tilt.
No.
The globe model and the seasons.
No. If you want, yeah, fine. Join the Flat Earth debate on Monday, and that's a perfectly... Have you got any questions specifically in relation to the topic that's on the table, i.e. wave particle duality?
Well, I apologize, because I thought you guys kind of got off topic on the waves and the photos, and you're going to talk about that later, photons or whatever. But no, I apologize. Yeah, sure. That's what we'll do.
No, that's cool. That's cool.
This is just too beyond me. So I'll let you guys.
No, it's not, man. It's not beyond you. You could get this.
Hopefully so. Okay.
Righto. Kim, mate, I've sat here all night chewing my lip. It's doing my head in, and it is hard stuff to wrap your head around. There's no point pretending otherwise. It's stuff you have to really sit and think about and actually define in your own head, not just have somebody tell you it's round.
Okay.
If you don't understand it, you forget it the next time. It's complicated stuff, but actually comprehending it has implications.
Surprised we didn't have anybody coming in asking about the gas pressure question from last week. I thought we'd be flooded with that rather than... My concern was going to be that we wouldn't have any questions on this particular topic, but it'd all be about last week's topic.
No, I didn't expect that, because the gas pressure... It's over. You can't. There's no way out of that one. There's no way out of this one, but this has maybe a little more loopholes in it that you think you can get out of it with quantum mechanics. Actually, there's not. It's an aberration. but with the second law of thermodynamics, you're not getting out of that one. Even second graders know that one. So.
Okay. Cool. Anyone else on the panel got anything to add? If not, I'm going to round out the live show. There will be an after show to follow, so if you guys are happy to hang around while I chat for the after show.
Yeah, that's fine.
Thanks for a good night, Nathan. I'm still sat here. I'm trying to burn down buildings with photos and not burn them down. Like I say, it is complicated because
having mice and dolphins look at the photos first.
Lassie.
I thought that was an excellent question.
Lassie would know, wouldn't she?
Yeah.
That's what I'm saying.
Lassie would know. Lassie's smart enough. Lassie's got the knowledge of the witch path.
There you go.
Okay, so for all the live... shout out to Colin Turner for the last minute super chat. Really appreciate your support. So with that, I will say a huge, massive... Well, no, first I prompt you, if you're watching this on Nathan Oakley channel, then stay tuned, as there will be an after show to follow. But if you're watching this on Nathan Oakley 1980, then a massive, huge, enormous thank you to all of the live audience for tuning in, hopefully smashing the share button, super chatting, subscribing if you've not done so already, and all that good stuff. Of course, a massive thank you to Quantum Eraser, Adam Meakin, Betty Van Velsen, and Arwin for joining the BALLBUSTERS panel, and of course a massive thank you to all of you who joined the debating panel on Google Hangouts. If you need something to keep you occupied after this show is over, then go to nathanoakley.com and check out the Flat Earth Debate Forum to keep up to date with the community debate. To round out this BALLBUSTERS, I've been Nathan Oakley, and I'll see you all in the next video.